Hello, this is your cabin crew speaking. Welcome aboard your flight into IoT with Microsoft Azure Airways. Before we take off for today's flight, which will hopefully be exactly 2 3/4 hours, we have the following messages, and we hope you'll give your full attention. Microsoft Azure Airways welcomes all of you to the flight, and to ensure everyone is welcome, we'd like to talk to you about our code of conduct and our commitment to accessibility. First of all, code of conduct. This is a virtual flight today, and we ask all of our presenters and guests, whether appearing on screen or participating in the live chat, to be aware of others, welcoming and respectful, to be understanding of differences, to be friendly, patient and accommodating to others, to be open to all of the questions and viewpoints, and most importantly of all, to be kind and considerate to others. If you have any concerns about anything you hear or see in today's flight, please email buzzcond@microsoft.com. And now, a note on accessibility. If you require captioning today, please watch the flight on Microsoft's Learn TV at aka.ms/LearnTV. After the flight, you'll find all of the links and resources at aka.ms/techdays/IoT-resources. Now don't forget that throughout today's flight we have live chat with a small team of moderators answering the questions, and also during the live show we'll have plenty of opportunities to ask your questions and answers. So sit back and enjoy the ride as Microsoft Tech Days, a flight into IoT, takes off. Hello there, good morning and welcome to Tech Days Flight into IoT. My name is Adam Jackson. I'm the Developer Engagement Lead for Azure at Microsoft UK. I am the, so to speak, the flight engineer on today's show, but I want to give a very warm welcome to our captain and first officer today. We have Cliff, Agius and Pete Gallagher joining us. Good morning.
Morning all.
Hey, how's it going?
Did we decide who was captain, who was first officer? That's
let's just not say. Let's let other people decide. But hey, I think maybe the guy with the flying experience should be captain.
Anyway, I think I just said I'm the flight engineer, but Cliff, you just mentioned that role doesn't exist anymore. So
not really, not unless you're an old Aleutian jet or kind of some Russian old Aleutian jet flying around the skies, or some old 707 or something like that. Yeah, on modern aircraft, there's just 2 pilots. Sometimes 3 or 4 on longer flights, but the one down to Budapest today is just going to be 2 pilots. So yeah, but we've got loads of crew to help us, which is awesome.
Brilliant. Well, I am going to disappear into the background and push all the buttons for today's show, but I'm going to wish you a very smooth flight.
Thank you very much.
See you in a second.
Thank you.
We'll bring you back in if things start going wrong, being as you're in the engineer role there, Adam, in the background.
Yeah, he's landing. So if the demo gods get us, it's Adam's fault. He's called himself the engineer.
That's fair. Yeah. So hopefully everyone can see the stream, which is the main thing here. But thank you very much for coming along to today's event. We're really excited about this. We've been planning this for quite a long time now. So there's been quite a lot of effort going on in the background to make this all work. Cliff and I, we spend some time streaming on Twitch, so this is kind of second nature to us to do the hosting side of this, and even more first nature to this for Cliff, as himself actually goes around flying planes for a job. So that's kind of the inspiration for this particular event. But if we switch over to the slides now, we can start talking about where we are today. So we're going to be simulating, if you will, a flight from London Heathrow to Budapest, which we chose mainly because it matches the length of this event quite nicely. It didn't take us that long actually to choose one. I think we went through like 3 or 4 different flights, didn't we, until we found one that was about the right length. Quite surprising, really. But it's good. So. What we're gonna hook up today, and kind of again the inspiration behind this event is to show you how you can connect up all of these Azure and Azure IoT services together in a way that makes sense, and we'll try and help you understand the reasoning behind why we've connected them up in the way we have and how they work. So we start here on the left hand side with the thing, as you will. So We need a thing for our Internet of Things, and in this case, the thing is going to be a plane, a simulated plane. But actually, we'll show you shortly that this is real information we're using. In Cliff's session, he'll be talking about how he is simulating the plane using the .NET Nano Framework that Jose Simoes and a team of open source people have been creating. An amazing achievement, actually, to be able to get a version of .NET running on tiny little microcontrollers. So I'm looking forward to Cliff's session. We'll be connecting all of this up to an IoT Hub. Now, if you've not heard about IoT Hub, then this is a cloud ingress point for millions of IoT devices. So you can create one of these IoT hubs, and then you can leverage bidirectional communications between Azure and your IoT device. What's great about it is that you can connect all these devices and they'll never receive a busy signal. This is a highly available service from Microsoft. And once you've got to the IoT Hub, then the rest of Azure is your playground because you've reached the cloud. It lives at what we'd call the edge of the cloud. So don't confuse that with something like IoT Edge. Really, the IoT Hub is there to be able to bridge the gap between your IoT device and the rest of Azure in a highly available sense. For Cliff's session, he'll be talking about the device provisioning service as well, which allows us a no-touch mechanism to be able to provision devices to the IoT Hub. If you think of large-scale production, you don't really want to have to be able to put some form of a certificate or a shared access key that matches exactly for the IoT Hub. So you need a central provisioning point, and that's what the device provisioning service gives us. Moving on, we're going to have our next speaker after my session and Cliff's session, which will be talking about how we can use Service Bus and Logic App and third-party services. And for that, we will have the fabulous Maria Anastasia Mustaca. And if Adam brings in Maria, then we can say hello to Maria Anastasia Mustaca.
Morning.
Hello, good morning.
Just checking out the lounge.
Exactly. She's in the lounge already.
Yeah.
Enjoying those free nibbles. Maria Anastasia, you are amongst other things, a student ambassador, aren't you, for Microsoft?
Mm-hmm. I'm a Microsoft Learn Student Ambassador, and I'm so looking forward to our flight.
Yeah, it should be good. So in Maria's session, and actually I'll be joining along with that, we'll be talking about how we can route errant messages that we receive at the IoT Hub out to a service bus and then onto a Logic app, and then we can reach out to third-party services after that. I won't delve in too much because there'll be too many spoilers for Maria's session, but we'll describe what each of those services are during that session, how they're hooked together and how we make use of them, and you'll be able to see that happening live. So thank you very much, Maria Anastasia, and we'll see you for your session.
Thank you.
So next up, we'll be talking about time series insights. And for that particular session, we'll have Sander van der Velde talking to us. So if we could have Sander on the screen. Here is Sander.
Yes, good morning. I'm joining a cup of IoT in the lunch already.
I like it. Very good. And Sander has joined us from the future, as his time travel box on the shelf will tell you there. Look, and apparently this whole session went really well. So that's good to have that confirmation, Sander. Thank you. Sander, what is it that you do as part of your day job?
Well, as my day job, I'm an IoT solution architect. So I'm building industrial IoT solutions, for example, connecting industrial stuff to the cloud.
Awesome stuff. And yes, Sander will be talking about how we can use time series insights to provide an engineering viewpoint of the data ingress that we're getting through the IoT Hub. So all of the flight data that's coming through there, we can expose into time series insights and leverage some insight into how that data's looking on the way in, from an engineering point of view. And thank you very much, Sander. We'll see you for your session in a bit.
You're welcome.
And then in the final session, we'll talk about Stream Analytics and Power BI. And for that session, we'll have Johnny Chips. And it's always like John Lunn, a.k.a. Johnny Chips. But either of those two, I'm sure you answer to these days. So if you could bring in Johnny. There he is.
He's got enough tech. He's got enough tech.
I'm here. Morning, first officer. Morning, Captain Cliff. How are you doing?
Captain Cliff. I like the sound
Captain
of that.
Cliff.
Yeah.
Saying you've got enough tech in your office set up there, Johnny, to make it look like the flight deck of a modern aircraft. So
Yeah, I'm very much at the flight deck as we speak. Yeah, how we all doing?
Yeah. I think you could be the control tower, actually, with the amount of kit you've got there.
Yeah.
It's incredible. Yeah. We're all very impressed with Johnny's stuff. But what Johnny's session will be talking about will be how we can grab that data, so similar to how time series insights work, but we'll grab it into Stream Analytics, and then we can pump that data back out in a format that Power BI can handle. And Power BI is a dashboarding tool from Microsoft that allows us to create nice, if you will, customer-facing dashboards, so that we can present the data that our plane, our thing is transmitting through the IoT Hub and back into Power BI. So that's going to be quite an interesting session. I'm looking forward to that. And in fact, what we can do is we can give you a sneak peek of what that data is starting to look like, because at the start of this show we actually started our flight, and so you can see in the bottom left hand corner is in fact there we are, then you can see that we've got some data points there already. So this is a dashboard view of that data that as you briefly saw there, Cliff was holding up his device that's actually sending this data through our system, and we can view that as we go. So what we're going to do is we're going to keep this dashboard around, and we'll keep referring back to that to see where we're at on our flight. But this is real-time data as it would be, and we'll explain in just a second actually how this data came to be. So if we switch back to my slides.
No, not me.
There we go. Actually, it will be Cliff. So, Cliff, do you want to explain to us about how this works?
I've got a couple of minutes to quickly explain to you where this data has come from. You can see that on the slide. This is taken from the FAA, the Federal Aviation Administration in the US. It's taken from their slides and their website on what ADS-B is. Now, ADS-B is automated dependent surveillance broadcast. So every aircraft receives GPS data from satellites, just like you do in your car or your watch when you're going for a run, that sort of thing. It receives that, it puts it together with a load of other data like its heading, its speed, its altitude, its flight number, some other emergency codes that may be used in the case of emergency, etc. And you broadcast that data out. There's no involvement from the pilots, hence the name automatic. And it's dependent on the aircraft systems, hence the dependency part, and it's just broadcast out. Then air traffic control on the ground can receive that data, and because it has all the extra stuff, which radar doesn't have, it can then update its radar images. Now, radar, if you've been anywhere near an airport, you've seen the spinning disc, the radar dish, that's normally near the center of the airport or on the outskirts of the airport. That rotates about 12.5 revolutions a minute, which means that they get an update on their radar screen about every 5-ish seconds. If we start to make a turn left or right in the sky, they need 3 dots to confirm that we've made the turn. So that's about every 15 to 20 seconds before they know that the aircraft started to turn. Where ADS-B happens instantly. If we go on to the next slide, Pete. The other thing we can do is next slide, Pete.
Yeah.
Along. Yep, there we go. The other thing we can do is not just air traffic control can receive that data. We can also receive it using the Raspberry Pi. You've obviously heard of Flight Radar 24, and you've used that website and looked up your friend's flight as it's coming into land, so you can make sure you get there just in time and reduce your parking charges at the airport. Well, you can, if you've got a Raspberry Pi, we've all got them, let's be honest. If you're watching this show, you love IoT, you've got one kicking around your house somewhere. There's probably collecting dust and not doing much. Well, dust it down, plug it into the power, go on to Flight Radar 24, and we'll share the link in the slides later. And you can, actually, it's at the bottom of the slide there. You can download an image, burn it on an SD card, and using one of those new Lex software-defined radios, you can pick up the frequency it's broadcast on, which is 1090 megahertz. Software-defined radio can pick up anything from Radio 1, your normal radio stations, all the way up to higher frequency stations like this ADSB. And then it will connect to Flight Radar 24, and any flights it hears, it will push that data to Flight Radar 24, and that's how they get their data. It's lots of people, Raspberry Pis around the world, that are collecting data and pushing it up. An advantage is you also get a full business license, which is $500 a year, just for plugging your Raspberry Pi in the wall and using a few milliamps, or probably a few hundred milliamps for driving your Raspberry Pi. So you get that. So what we did, I've got one. I've had it running. It's up on a shelf in the corner of my workshop here. It's been running for years. And with that, I collected the data from a flight from London Heathrow to Budapest, and that is the one that we're following along today. And as you can see down there in the little window, so it's just taxiing out for departure London Heathrow, and we'll follow that along. I'll come back later and explain to you how we're sending that data up to cloud. I think first Pete wants to talk about how he simulated that data and using no hardware, so he's got no devices. It's all being done with stuff in the cloud. So yeah, over to you, Pete. You and Maria Anastasia, I believe.
Well, me first. And then, so I'm going to flick straight into demos. Actually, the first thing I want to do is show you how easy it is to create an IoT hub. So if I get the right screen, here we go. So I'm in the resource group in Azure for our whole infrastructure here. So we've got a whole heap of stuff in here that we've got set up and working. We're not going to create any of this live today because we're nowhere near that brave. So we've got this all just running in the background, and we're going to explain how that all works. But I thought, being as the IoT Hub is central to what we're creating here, it would be good for you to be a bit more informed about how you go about creating it. It's rather easy, actually. So in here, we can click Create, and we can search for IoT Hub from our list. And then in the marketplace, we will find an IoT Hub just here. So if I click on that, then we can hit the blue Create button. And I'm going to take you through all the way to the end. I'm not going to actually create the IoT Hub because that's senseless, but you will see the steps involved to be able to get to where we're at, and then we can flick across to the live one in a bit. So we start out on the Basics tab here on this screen, on this blade, and we get to choose our sponsor subscription and our resource group, which have defaulted to the resource group that I began in. And then we can give our IoT Hub a name, so something like Tech Days 2021 or something like that. And no one's used that, which is nice. This is globally unique, this name, because it surfaces a public endpoint out to the public internet. So this has to be a unique name. So if I just choose IoT Hub 1, you'll see that will have been taken already. So we can't have that. So Tech Days 2021 will be fine. Then we choose a region. Now, if you know that you're going to be operating in a particular area of the world, then you're best off creating your IoT Hub close to where your devices are so that you can minimize the latency between your devices and the rest of the cloud. It can become very important when you start scaling. For me, I'm just going to choose North Europe, actually, because that's going to be good enough for this. Then we can move on to networking. I'm not going to deep dive into this, but it's entirely possible that, as was said a second ago, you might not want that public-facing endpoint for security reasons, and so you can limit that endpoint to your own private network, and that's what this particular screen lets you do. For management, this is a really important screen, so most of your decisions need to be made at this point, other than the really difficult job of naming anything. The first option that you need to choose here is the scale and tier. So actually, if we look down here in this box at the bottom, we can see that we've got 400,000 messages per day we're allowed on this particular scale and tier of the IoT Hub. Once you reach that 400,000 messages, then things will start becoming throttled, or you'll lose messages. So it's a really important calculation that you need to do to work out how many messages you're going to be sending from your devices up to the IoT Hub, as well as the other operations that are likely to affect it. On top of that, then each IoT Hub tailor scale and tier will have its own cost associated with it. You can see that this one is currently £18.63, so quite cheap actually. And then we can see on the right hand side that we've got various services that become enabled depending on which tier you choose. if I choose the basic tier and scroll back down again, you see at this point we lose cloud-to-device commands and IoT Edge and device management. The reason for that is that we lose the facility to send cloud-to-device messages, which is required to be able to get these services to work. But it could be that you're not interested in cloud-to-device messaging, and you'd far rather save £11 a month. It could be quite it could become quite important when you start scaling solutions out. So if I switch that back to the standard tier again, if that 400,000 messages isn't quite enough for you, you can add more what's called units of that. And so you can see down at the bottom of the screen now that we've got 2,400,000, 12,400,000, but the cost is going up by quite a lot at that point. So now we're at £577 a month. Actually, if I scroll that all the way to the very right-hand side, you can see that it can become quite expensive, £3,726 a month. And now we've got 80 million messages, but even that might not be enough. So what we've got here is we've got some other scales that we can choose. And if I skip up to the S2 tier, we can see now we've got 6 million messages and £186 a month. And likewise, I can go up to the S3 tier and we get 300 million for 1,800. So there's plenty of options for customizing exactly how you want your IoT hub to work. And all of that is going to be a maths-based solution to figure out which one you're going to need. What's great is that you can scale up and down between these tiers for free. So you don't need to worry too much if you make the wrong decision. You can just go ahead and change that after you've deployed. It's fine. Something else to bear in mind, you can actually create a free tier of this. So it gives you everything the standard tier gives you, aside from it's only 8,000 messages a day, which it's not a huge amount, but it's enough for prototyping. And of course, it costs nothing. You don't get Azure Defender for IoT, but you perhaps don't need to worry about that for prototyping anyway. So that's pretty much the only part of the IoT Hub creation process I needed to show you. But once you've created that IoT Hub, then you'll have that in your resource group. So if we go back, then if I scroll down here a little bit, then we have an IoT Hub just here. And I'll quickly show you what that looks like. So we've got some essentials at the top that I'll minimize away. When you come to this screen, you get some basic metrics. So we can see here at the top that we've used 113 out of our 400,000 messages, and we've got 4 IoT devices registered to this IoT Hub. We can see a nice graph of the messages being used here too. And then the device to cloud messages version of that, and then the number of connected devices. So this is a really handy screen for metrics. And then the total number of IoT devices. So in Cliff's session, in the next session for Cliff, if I don't destroy my microphone while I'm doing it, Cliff will be using an ESP32 to be able to send the flight data that we grabbed from flight data 24 and send that directly from his ESP32 up to the IoT Hub. But you can do this without needing a physical device. And so if we go to the Raspberry Pi IoT simulator, and I know that there's a link for that, then what I've done is I've rewritten the code here that comes with that simulator to be able to send this same flight data up to the IoT Hub. So it will send the exact same data that Cliff will be sending from his ESP32, but without the need for an actual device. So I'm not going to go through the code in any great detail, but you can see here's our flight data. So we've got all of that flight data just as one big long array. And there's the link to the simulator on the screen now. So each of the data points that we've grabbed from that flight data 24, and I think it's flight data 24, I can't remember exactly what it's called. We've grabbed that and I've just converted that to a JSON array, and I've just got that sitting there in the code just there. And then we just send it out to the IoT Hub by grabbing it here and sending it as a message. So not particularly complicated. And in fact, if I start that running, then we'll see it'll start sending those messages at the bottom, and each one of those messages is going along now. And what I've got is my own version of the dashboard. If I grab that on the screen, and there we are. So you can see that as it's sending those messages, and I'm sending them a lot faster than Cliff will be actually. I think I'm sending these probably once every 5 or so seconds, and you can see now we've got quite a few data points already going there. And so you can simulate your whole flight in a matter of minutes. I think it took about 10 minutes for the whole flight, but then that's up to you to work out exactly what you want to do with that. But yeah, so that kind of gives us where we want to go to with that. So I think at that point we can get Cliff back on the screen and we can start moving on to the next session.
Hello.
There he is.
Yeah, I'm just being told that the flight's delayed at the runway, so I'm just checking in and just making sure that all is well. It looks good to me, so I think it's just it's waiting in the traffic for departure.
Yeah, it's on the ground for a long time actually.
Yeah, it's a good 10-15 minutes. It's on the ground. It's obviously this radar data that we've grabbed, this ADS-B data. It was a busy day at Heathrow, so yeah, it looks like it's just sitting there waiting at the moment. So yeah, we'll wait for it to see its departure. We're getting messages in our little chat here to say that yeah, they're worried that it's not going anywhere. But I'm fairly happy that it's moving along.
Yeah, that's fine.
Yeah.
So I think probably before we move on to all the other sessions, Adam, would you want to put the schedule up, the session schedule there, and we can quickly just show people what they can expect.
Yeah, it looks like it's moving again. I think everyone was just panicking.
Let's do something.
Yeah,
here we are. So I've just finished my little session there on the Raspberry Pi simulator, and we've got a few minutes here for some Q&A if we'd like. And obviously, if you've got questions, then do feel free to put your questions in the chat. We've got various different methods to get in touch with us, so we're more than happy to answer any questions. Cliff, it's a little bit of a tangent, but you deal with simulation quite regularly for maintaining your pilot's license, don't you?
Yes. Every 6 months, as an airline pilot, we go into the simulator. And if you don't know, if you're watching this and you don't know who I am, by the way, I am a real life airline pilot for a major UK airline. I get to fly a 787 around the world. Is my day job. And when I'm not doing that, I geek out with IoT and Xamarin or Maui. There you go, using Microsoft Maui. So I do either mobile or IoT development as a freelance developer. I love IoT. I was an engineer in a previous life, and yeah. So every 6 months we go into sim. My sim check has come up at the beginning of December, so I'm due back in the sim, and we hand over our license and thus our career to a training department. And we spend 2 days in the simulator being tested, examined, and trained. They call it training, but really you're under test the whole time. And the idea is you walk away from that 2 days having learned something new. I've been doing it for 20 years now. And every time we go in the sim, it's not because we're stupid, but there's different ways. There's better ways of doing things. You see an incident. It doesn't have to be an accident. An incident that happens anywhere in the world with other airlines. That data is shared. We're a really open culture in aviation. And you learn best from your mistakes, and you can learn just as well from other people's mistakes. So if something happens, or we start to operate to a completely new airport we've not operated to before, we'll practice that in the simulator, so that when we do go there, it's not new. It's like, oh, I didn't know about that big tall building there, Burj Khalifa as you're going into Dubai or something like that. You've seen it in the simulator, you've practiced it, you know about the hills, the mountains, the wind comes in from an odd direction. If you're going somewhere like, I don't know, Gibraltar, the wind there is because you've got the rock of Gibraltar, the wind comes around the rock in really fun angles, so you can't go there until you practice it in the simulator. But we'll also, revalidate our license and so we'll practice all the emergencies, engine failures, fuel leaks, hydraulic leaks, electrical failures, air traffic control go, missing, and you've got to do it all, via special procedures, all these sorts of things, problems in the cabin, people having heart attacks and stuff like that. We'll practice all of this and the drills and procedures. And at the end of the 2 days, hopefully they'll sign our license, give us a tick in the box, and we'll go back to flying the line. If we don't pass the test, they don't sign our license, we cannot fly passenger aircraft. So, like I said, we hand our career and our license across. As I say, I've been doing it for 20 years. I've got friends and colleagues that have been doing it way longer than I have. And yeah, it's part of the game, and then once a year we go and see the doctor as well and get prodded and probed. It's a good 2 hours of being tested to make sure you're medically fit and you're not going to keel over on the flight deck. But yeah, plus there's also 2 of us minimum, captain and first officer, to make sure that one of us does keel over, there's a spare pilot. It's all about having safeties and spares, and we've even got that today. This is the device that's sending the live data. It's plugged into battery just to prove that it's not plugged into computer and the computer's cheating. and you can see it says main on that, and then we have a standby one there, which is hot standby, just in case all things go horribly wrong and we need to unplug this one. Massive battery, 28,000 milliamp hours, so that should last a couple of days running this little ESP32. They're about £10 each, $10. You can get them cheaper, but I buy them quite often with this little motherboard part on the bottom. Otherwise, they come with just little header pins like this. But I find this motherboard means you don't need the special little FTDI programmer. So it only costs a couple of £pounds extra. So I buy them like that, a lot better. So, but yeah. Apparently, Adam's saying we got some questions in the YouTube chats, Pete. So I don't know if you want to read those out and see or if Adam can press funny buttons and get them to appear on screen.
Do we really need a ESP32? Because yeah, exactly.
Yeah.
So there's some good reasoning for using an ESP32. One is that if you discount the Pi Zero, which you shouldn't do because it's awesome, the ESP32 you could buy 2 or 3 for probably 10 quid. So way cheaper, but also you don't need an SD card to be able to run this thing and set that all up, and a keyboard and a mouse. So the difference between a Raspberry Pi, of course, full computer, and an ESP32 microcontroller is enormous actually. Yeah. But for standard sort of telemetry stuff like this, measurement and telemetry, actually I like Arduinos for that because it's simpler. You've removed the whole operating system requirement from it.
Yeah, I mean, if you're using the Raspberry Pi, you're running Linux, aren't you? So you effectively do have a full-blown computer. So whether you're using Raspberry Pi or your PC, your laptop, there's not much difference, is there? Except the Raspberry Pi obviously has GPIO, general purpose input-output pins, so you can drive an LED, or you can read in your temperature and humidity, that sort of thing. But we wanted to prove the fact that you don't need that. You could go really, really, really low level and use a MCU, a microcontroller unit, send this data to the cloud as well. Most people don't think you can use that. Most people think you need a computer at the edge. You need to run like the CSDK or the Azure IoT C SDK. So you have to program in C and stuff like that. No. We're going to use .NET, C#, and we're going to use the awesome Nano Framework today, and we're going to run it on a $10, £10 device.
And that's it.
Yeah.
Is it a regular ESP32 actually, Clifford?
It's
an
ESP32 standard.
CAM.
The only reason I used the ESP32 CAM board is because it's got an SD card slot, and we wanted to put flight data. There's quite a lot of it. There's nearly 400 data points for our flight to Budapest today. So that wouldn't fit in the memory of an ESP32 because an ESP32 only has 4 meg. And by the time you've got Nano Framework in your code and all the other bits, you've used up half of that. So you couldn't fit all the rest of the data in there. It just wouldn't fit. And because obviously you need some memory to actually run the code. So that JSON packet needs to be, because it's .NET, you need to obviously take the JSON, you need to deserialize it into your model, and then suddenly you've now got a double copy of your data, because obviously you've got the JSON version and the model version. So I'm just running it off an SD card. There's other boards you can get. You can get the ST Electronics boards that run Nano Framework. You can even run it on there's community involvement as well to run it on the Raspberry Pi Pico as well. I'm not sure how far along now with that, but I know it started and it looks quite promising. But yeah, I just used this. I had a couple laying around anyway, and for a project I'm working on for a client. So it's got an SD card and it's got a little camera as well. So yeah, and it looks like our flight is on the runway, Pete, and he's just gotten airborne. So we are passing 2,000 feet, Johnny tells us.
There's a couple of other questions in there as well. Vipul asked if the Raspberry Pi is the only one. I think actually what Vipul might be asking is, and sorry if I'm wrong, is the flight 24, the IoT 24. Is it just Raspberry Pi that's supported for that? Do you need a Raspberry Pi
for the Flight Radar 24 data? Yes,
I think,
it's because they have their own SD card image. So you burn their image using any number of your favorite SD card burning software. Belina is one I use just because I like it and it looks colourful and it's pretty. But yeah, use any SD card burning image. You take their image, you burn it onto the SD card, plug the SD card in, and that is all you do. It's I think then you log in with your account details on the on their website, and it sets it all up for you. So they've obviously got some some IP in there that they don't want to share too far and wide. So that's the way they run it and make it work. So but yeah, we've all got old. I mean, you only need a Raspberry Pi 3B. I mean, they're what, £20, £25 now, the old ones. You've probably got one collecting dust in a box somewhere under your desk. Just drag it out and plug it in. Have some fun.
One final question was what's the message size? And it's a few hundred bytes. And in fact, Cliff will probably show you that during his talk coming up next. Adam, before we move on, did you want to just flick to my slides? And I've got the links from the part that I was speaking about here. So if you want to learn a little bit more about Azure IoT Hubs, then you can go to all of these links. All start with the aka.ms/tech days. /IoT, aside from just a couple of them. But yeah, so if you go to aka.ms/tech days/IoT/hub, then you can find out a little bit more about the IoT Hub. And then for device management, it's DM. If you wanted to take your learning a little bit further and perhaps improve your career prospects in the IoT space, then there's a certification that you can take from Microsoft, which is fantastic. I say that because I helped create the certification. So if you go to techdays/IoT/exam, then you can find out a little bit more about that exam. And myself and a few other authors, including Jürgen, who is manning the chat along with Gosha today, we helped create a certification learning path there on Pluralsight. So do go and check that out, and that should give you everything you need to pass that exam. The IoT simulator that we showed there, the Raspberry Pi IoT simulator at IoT/simulator. All of the code for today's event. So that includes that simulator code, and the code that Cliff will show you shortly is available on that GitHub link just there. So github.com/CliffAgius/TechDays2021. And don't forget, the whole event is also underpinned by the 30 Days to Learn It IoT Challenge, which is a fantastic collection of Microsoft Learn modules that will help you to upskill your IoT knowledge as well. So if you go to aka.ms/techdays/IoT-challenge, then you can go ahead and do that. And with that, we'll move on to Cliff's session, because now we're 2 minutes over time, and we don't like being out of time.
Don't be late.
Flying.
Don't be late.
It's bad.
It's headwinds. That's what it is.
Yeah, that's what it is. So thank you very much, and we'll move across to Cliff Agius and Jose Simões. Is Jose going to be sitting in with you on that session, Cliff?
I think he is. I think he's going to sit in. He's the expert, so he can answer all the questions about Nano Framework, because he is one of he is the maintainer with a few other people. But yeah, he's the head man over at Nano Framework. Hi, how are you?
Hello, I'm fine. Hello, everyone. Hope you're having a good flight so far.
Yeah, hopefully no turbulence. You've sat back, relaxed. We're airborne, and we're just on a it looks like a bookless departure today. So we're departing down to the south, down towards Gatwick, and we'll head out towards Epsom, and then down across the coast and out towards France. So yeah, we're passing 6,000 feet in the climb. It's looking like a nice slow climb out, just to make sure we don't bump into anyone that's coming into Heathrow. And so we switched across to my slides. I'll try and catch up these 3 minutes that Pete lost us on the way. As I mentioned earlier, my name's Clifford Agius. I'm an airline pilot, and I fly 787s around the world. When I'm not doing that, I work a lot with IoT and Xamarin / Maui, as it will be when it comes out in March, April next year. Azure MVP as well, and you can check me out and catch up with me on Twitter and follow me there if you have any questions about this after the event. But let's move on and talk about this bit here. So Pete shared the diagram earlier, but the bit I'm going to talk about is how we took the data from Flight Radar 24 and added some bits to the JSON just to make it a bit more interesting. Things like the wind and temperature, we took that from the National Weather Service in the US and overlaid that data to give us a realistic what was happening on the day weather report. And we are now running that on our little ESP32 plugged into our big battery. So I'm going to talk about the Nano Framework part and how we got the software to run on the ESP32. But I'm also going to explain how we connect it to the IoT Hub. Now, We could go direct to the IoT Hub, but then that means we have to share the IoT Hub connections and SAS tokens, etc., on a small device, which, to be honest, is not ideal. And if you've got one of these to program, that's fine. If you've got hundreds of them to program, not so good. So what you might do is use the Azure Device Provisioning Service. That allows you to burn the code onto your device, and then your device talks to the device provisioning service, and then it says, actually, I want you to connect to this IoT Hub. You may have hundreds of them. We're doing a flight across Europe, so you may have one in the UK, may have one in Germany, one in Amsterdam, one in France. You could be anywhere across Europe with an IoT Hub. So you can tell it that you want to connect to the one that's got the lowest latency, i.e. the closest IoT Hub, and device provisioning service will work that out for you in the background, and then say to your device, I want you to connect to this IoT Hub. This is the name of that IoT Hub, and this is its connection string, and this is its secret key to connect to. And your device will talk to IoT Hub as well. The other parts, I'll just quickly flick through these because Pete talks about those, and you'll hear from the experts on those areas a little bit later in the show. But let's talk about our device. I want you to understand how low level and low powered this is. These ESP32 CAN boards, like I say there, you can see in the picture, I buy them with the motherboard just purely because it's easy. Otherwise, you have to use a little programmer board because they've got no USB port on them, so you need to program them over serial comms. So that motherboard just takes care of that for us, and it also breaks out a reset and boot button. You see, it doesn't have that much in the way of GPIO, general purpose input output, but it's enough what we want. But it's 160 megahertz clock speed, so which isn't a slouch for an IoT device. It's got 512K of RAM and then 4 meg of static RAM they can use as well. So we've got best part of 4.5 meg, but being an MCU, you can only really address 4 meg of that RAM. It's got loads of other things. This one's also got camera, which is why it's called the CAM. It's got a little camera built on board as well. And it's got lots of sleep modes, which means when it's not doing something, we can put it to sleep and then get it to wake up on a trigger as well. But we go on. Nano Framework, you can see I've got the logo in the top corner there. If you go out to the Nano Framework website, you'll see all the docs and learning materials out there as well. And the GitHub has got all the samples, etc. And we'll show links at the end of the slide deck that you can go to there as well. But the way it works, you have your hardware, in our case, our ESP32 board, had a hardware extraction layer, which is where the Nano Framework extracts away the hardware for you. Then you have a platform on top of that, which is the ESP32 platform, or the ST Electronics one as well. And then you get into the common language runtime, which is, as .NET developers, what we know. And above that is the part we know. So Nano Framework takes care of everything below that. Obviously, it doesn't have the complete common language runtime in there. It doesn't have things like generics. They're coming. Jose can talk about that later in the Q&A maybe. But it does have all your normal standard things, but it doesn't have the things you don't need. You haven't got a full powered machine and computer here with a screen. So why do you need all the graphics libraries, for example? So we can talk about that. And then obviously you can bring in other namespaces. The Nano Framework have rewritten some of them that are bespoke for IoT devices. That you'll need things like the threading frameworks, etc., because you don't have hundreds of cores and the likes. So they've been rewritten. And then you have the green box, which is your code, or the code that we're going to use today. So as I said, our device connects to device provisioning service. This all looked very complicated in the arrows, but I'm sure if you go out to the docs.microsoft.com for the device provisioning service, I'm sure Adam will put a link up on the screen shortly. You can see the device talks to the device provisioning service, which is number one. Device provisioning service sends back the device the connection. It then talks to the IoT Hub and sends back the connection string back to the device. And then device 7.8 then talks to the IoT Hub directly, and it's got that connection and it starts sending the data. So let's talk about a demo then. Let's go out to our this one here, which is I've got a brand new ESP32 here. It's just plugged into my computer. It's on COM3, so if we went out and looked at my computer's device hardware, it'll be on COM3. And we are just going to load the Nano, which is the Nano Framework firmware.
Flasher.
Oh, that's not good, is it? Let's try that again and just see if it's a. Oh no, it doesn't like it. The demo gods have got us. Okay, well, I was going to talk about I was going to set this device up and connect it to the network, but it doesn't seem to be happy finding that CloudSmith repository. Well, the show must go on, so we'll continue and we'll talk about the other parts of it. So what we'll do is if we go out to I've got too many things open. We'll go out to the software and the code. We will look at the code. So we've got all the Nano Framework libraries, the using statements, as you know and love, up the top here. We can even read JSON in, which is what we're doing, and we can connect to Azure, which is kind of cool. And then what we'd do is we'd set up our Azure device provision, so DPS settings. So we need to give it a registration ID. So we call this, and this is the ID of the device. This would be set in the factory. We're manually putting it in, but if you're using an off-the-shelf device that you're buying from a manufacturer, they tend to have a TPM module and the likes as well, and you can have them burnt with an ID as well. But we're coding it in here, so we'll call this speedy 01, because this one's going to send the data every second. It would if I could get it to work. And then we need a DPS address. So if we go out to our dashboard of our flight, we've got our IoT Hub here and our device provision service here. So we're going to the device provision service. You can see here we've got the global endpoint and our ID scope. So we need the global endpoints. So we take the global endpoints and we go back into there and we put that into our DPS address, because that's the address of our DPS service. Now the ID scope there, we need that as well. So grab that ID scope there and we'll stick that into there. So now we've got this. Now it's asking for a SAS key. Now this gets a lot of people starting out new with IoT Hub and DPS and everything else. X509 certificates, you can see at the top of the screen there, and it gets everyone. It's like, oh, I don't know what that is. Where do I get one of those? And then you read the docs and it says, use certificates from a certificate authority rather than X509 because self-signed and not safe and secure, yada, yada, yada. I'll leave you to read the docs. But we're going to use an X509 certificate, self-signed by us, and we'll use that to connect. So what do we need to do? So we need to manage our enrollments on the left here, and we can have an individual enrollment just for an individual device or a group. So we've created a group because we've got a group of devices. So we go into our DPS group here. You can see we have some connection details here, and you can see the registration records. At the moment, we've got Nano Framework 01, which is the one that's sending the flight data, which is this one here. We have that. So we'll go in here and we've got this symmetric key here, and it says primary key. Now, because it says symmetric key and primary key, you think that is the key you need to use, but no, sadly it's not. The one you actually need to use is you need to create yourself. You need to create a self-signed SAS key. Now, there's in the docs, there's derive a device key, and I've used Windows because I'm going to use PowerShell, and you've got this PowerShell script here. So what you need to do is take that that key there. So we'll copy that key and we'll paste that into this PowerShell script where it says key. The reg ID will be the reg we called it in our registration ID, Speedy01, and then we run that whole script. Now, to save a bit of time, and you don't really want to watch me typing, I've done this already. So we will paste all of that in there. You can see it's gone through it all really, really quickly, and we do this, and it gives us a derived key. So now we can copy that, and I'm quite happy with the fact this is on the show, because at the end of this, we're going to destroy all of this anyway. Or the other clever thing you can do is you can go back into your where's it gone? Where's it gone? There, and you can regenerate the keys, and it will change the keys, and then nothing will connect. But we're not going to do that because obviously we want to leave it running. So we've got this key here that we've copied, and we can go back into our code and we can paste that into there. Then we can connect to our device, and we can click F5, and it will burn it up to our device. But because for some reason that didn't work earlier. I'm just going to give it one more try, just to see if I'm definitely on COM3. It's got the right data in there. So no, it's not worked. What I would do is connect it, and then we'll go out and connect it to the device. But because that's not working, and the show must go on, we'll talk about it a bit more. So what would happen is, under our DPS group here, it will connect up, it will talk to IoT Hub, and then connect out to IoT Hub. So we go out to the IoT Hub. We'll see that under devices.
Cliff,
Yep.
can you make a text a bit bigger, please?
I could. Yep, there you go. How's that?
Thank you.
Sorry, apologies. Hopefully you can see that. We can share the slides on that later, which shows this. So you can see here we have our 4 devices: Peak Simulator, and Johnny Chips has got one that he's using for his talk later. We've got our Nano Framework 01. So we go into this. This has got some details in here, and again, some people think that we use the primary key here, but no, because we're using DPS. That just connects, and then you're good there. So we can look into here. We can look into the device twin. And we can see that our device that is running, our live device, this little one here with a battery to prove it's not plugged into any computer that's really doing the sending. Sorry, Adam, I noticed you're doing it there. There you go. So we have a big battery and an ESP32 there, and it's the main one. You can see here, we're reporting out the SDK. That's the Nano Framework SDK that's installed on this board. Total memory, how much of it is free when it connected to this, and the fact that it's true, and the device platform ESP32. But we can also go out and see the fact we can send direct methods, which is how we start and stop the flight. I'm not going to do that because we want it to work, and we can send messages as well. But how does that all work in the code? So we've connected to DPS. So we come into our main method. It's just like a console app that you run when you run your console apps. And we come in and we're going to connect network helper. We're going to connect to the Wi-Fi. And when we do that, we can program the Wi-Fi credentials into the device using the Nano Framework tooling. And I'm just looking. I don't think I have the on this machine. I've done all the setup, all the hard work, all this practicing on my laptop, which is sitting there. And I've come out to my workshop because my wife has come down with COVID in the last few days. So the whole setup has changed this morning, and I've not thought to install the Nano Framework tooling in this Visual Studio, which could be why it's not connecting to that device. But anyway, we'll carry on. So COVID has caused the problem. So we connect out to Wi-Fi, get Wi-Fi credentials, and you can see here, there's nothing special here. We're just connecting out and connecting to make sure we get Wi-Fi, and eventually, hopefully, it says, yay, connected to Wi-Fi. And then we go out and get our flight data. So if we go out and no, not the settings, my keyboard has suddenly decided to not play ball. It keeps turning it on. There we go, out to flight data. And then all we're doing here is we are reading in the storage. So when this is created, it initializes the SD card. So you can see here, flight data store initializes the SD card. So it sets that up. It sets up the SD card. It sleeps for a few seconds while the SD card sorts itself out. These processors are great, they're quick, but they're not your full-blown PC. And it sets that up, and all we do is log out. I would love to have shown you this. Log out the fact that the drives are there, or have a D drive, which is the SD card. We then read that data in. So we read it in the file stream, and we read in the file path, which is your D colon, and the counts, and then .json. So on the SD card, there's 8 files, 1.json, 2.json, 3.json, which are in the repo. They are in the, not in that one, they're in the, not that one, and they're in the flight data, they're in the sections for the SD card. So you want to build this at home, you can go in here, and they're the files you copy the SD card, and if we pop into one of those, we will see that it is just the SD card data. So we can see that there is one report. So it gives the call sign, the latitude, longitude, altitude, vertical speed in feet per minute, seconds to next report. So it waits 39 seconds before it does the next report, gives a speed, direction, outside air temperature, etc., etc. So you copy those over. So it reads the first file, and the reason we've broken it down into chunks of 50 data points is, again, back to memory management. So we've broken it down, and we just read 50 in and then use those 50 to carry on programming. And then we connect with DPS. We set up some events, which are these lines here, where if we get a cloud to device message, where you can send a message from the cloud down to the device, it will trigger that. We can do twin updates, where we can update the twin. So if the twin has been changed in the cloud, it'll update our device as well, which is fantastic, which means you have full control. And then we have a direct method callback, so you can fire that direct method, which is where we're starting to stop in the flight. We can fire that direct method, and it'll call into our cloud as well. That's it for our main method. Now we just have things like change flight status, which is a direct method here. Is called. So if you change flight status from start to running, start or stop, it comes in here, and all it's doing is if it sees stop or start in the little JSON packet you send, it will start and stop the worker thread. So it will suspend it or start it, and then it will send back a status, as well as updating the twin report to say it's either started or stopped. When the flight's finished, it resets the file count back to 1. So back to that 1.json for the first packet, so it's ready to start again, and it stops the flight as well. Connecting with DPS though, we have our X509 certificate. Now this is it's better to read the docs than me trying to explain it, and there's a link at the end of the notes as well. But we have the root certificate authority, and then we correct and provision our device. And then this is where it comes back and shares all of its data, and we can get all the information about the hub that's connected, when it connected, its device ID, etc., etc. Is connected up to the device. Eventually, we need to open the IoT Hub connection. So now we have our client, we have all the data that we need back from DPS. It's assigned hub, it's device IT, it's SAS key, etc., etc. We can open that connection. And if it didn't open, we'd send a message and close the connection. But if it did open, then we'd say, right, well, give us our device twins. So what messages, what has been set up in our device provisioning, and you can set it up so that when a new device connects, you can tell it to, I want you to send me updates every 5 seconds, or I want you to be, any number of settings you can think of, you can share with the device, and then those settings can be used by the device to then manage its connection as time goes forwards. So in the update, we're just getting the native memory. So this is a Nano Framework library, and we're getting those times. We're just massaging them from bytes into megabytes. And again, look at this. This is just normal C#. I haven't had to think or go and digging into docs or anything else. It's just normal C# parlance here. Even little tricks like putting .00 on the end to make it a double calculation, so that it gives us 4.52 megabytes rather than just 4 megabytes. Just little things like that you do as a normal .NET C# developer, you can do in here. And the worker thread, all that's doing is coming through, is checking if one of the warnings has been set, the cloud device warnings. We can set an altitude area where it fakes the altitude to be 40,000 feet, or vertical speed dive, so the aircraft's got into a bit of trouble, it's diving at 6,000 feet per minute. We can set all of these, come back to ice crystallization later, and then we update those and send the message. And this is the line that sends the message up to IoT Hub. It has a cancellation token, so it takes more than 2 seconds. It cancels this, and that's just good development technique. So it sends that message up, which is just the JSON that's been serialized, or that line of the JSON has been re-serialized and sent back up again. And then we log it out if we're connected. We can even set breakpoints and run the breakpoint. I'm really annoyed that device hasn't connected, because I'd love to have set the breakpoint.
Cliff, you may want to show the Device Explorer window. That's why it's not connecting.
Sorry?
On Visual Studio, you don't have the Device Explorer window showing.
As I say, I've got it all set up on my laptop, but because my wife's come down with COVID, and we're trying to isolate being set.
If you go into Visual Studio View, other windows, you can.
Yeah, I'm not sure it's other windows.
Other windows, yeah.
I'm not sure if it's on.
It is there.
Oh, it is there. It is there.
Yep.
Excellent. Yeah, there you go. So there you go. So here's our devices. So this is where you'd use the. I'm not sure it's going to find it as a problem. I think that could be why it's not.
it's connected, it should pop.
Yeah, it should pop up with our device there, but it's not for some reason. I'm aware I'm over time anyway, so
Okay.
yeah, we'd update the twins. I'll try and get this working, and maybe we can come back to it later. And then all we do at the very end is we convert the degrees that the heading is into a string, and that's purely so when Power BI uses that data, it can display north, northeast, northeast, that sort of thing as well. And these are our warnings here for our emergencies that we can set up. So if we go back out to our IoT Hub, is it's not there. Azure IoT Explorer. This is another. My computer's not playing ball today. It's not happy at all, is it? This is a fantastic tool. In the portal, you can't monitor the live data coming in without putting it out to a storage endpoint. So you can use this tool here, Azure IoT Explorer Preview, and you can send direct methods from here, cloud device messages. You can look at the device twin, which is exactly the same as in the portal. But you can also start the telemetry as well. So you can click start, and it will receive an event. So the next event that comes through, hopefully I didn't click it at the wrong point and we have to wait 30 seconds. I think we're all around sort of 10 seconds-ish in the middle of the flight. But it will show the JSON blob just here as well. And that's, I've obviously clicked it at just the wrong time, haven't I? Yeah, it's not going well. So what we'll do is we'll go back to the slides, and while that's there you go. There's a data packet there, so you can see there that's a data packet. It shows you an NQ time, so you can see it's live because 1 minute past 11, which is the exact time GMT here. Or so you can see this is all live data that's coming in from this ESP32 that I'm waving around in my hands. So we'll quickly pop back to slides, and we will. Quickly go on to links. So device provisioning service, aka.ms tech days. You can go out and read the docs of device provisioning service, the costs, etc. Nano Framework, sadly, because it didn't work for me, but Jose can talk about it a bit more in the Q&A. Go out to nanoframework.net. You can use .NET, your C# .NET skills on IoT devices like this. Awesome. If you want to install that IoT Explorer and monitor the data, you can go out the links there. That device key bit, it took me a while to work out how to do that. There's a link there, ak.ms and the device key. We can go and get that PowerShell script to pull it down. I've also written a blog post about it. I think we've all written blog posts, which we'll share in the next coming days about our little sections, which you can read about as well. A Cloud Skills Challenge and the GitHub repos at the very bottom as well. So hopefully you can use those. Let's go and check out, Adam, where our flight is at the moment, and maybe catch up a bit of time with a slightly reduced Q&A. So where are we at the moment? We're way across coming across. It's a little bit blurry in my screen at the moment, sadly.
We are over France now.
Yeah, just north of France, aren't we? Just going past Brussels, I think. So Jose, you're the one of the main leads behind the Nano Framework. I'm new to it. I'm as you know from the Discord chat, I'm often asking questions, etc. But do you want to give a bit of a background of where Nano Framework come from and where it's going in the future? Now that it's obviously a .NET Foundation member project as well.
Yeah, sure. This was started back in 2016 as a kind of a spin-off of the defunct .NET Micro Framework. It's way different than it was now back then, and basically we tried to make it simpler. As you were seeing, as Cliff was going through the code, that's not .NET C# code. Visual Studio that we know and love, and all the awesomeness that is working with it. You just have to, that's the part that was failing on Cliff. You have to grab a Nano Framework flasher and flash your ESP device as it was doing, and go back to Visual Studio, install the extension, and you are good to go. Everything there, it's distributed with NuGet packages. If you can go back to Visual Studio and just expand the reference there so people can see how this looks like. So this is basically you pull in the NuGets that you need. We have a bunch of them, so this can be really up to the point that you don't waste any flash space on your devices. Worth also mentioning that on this demo, Cliff is using the ESP32, but we have ports for Cortex-M devices, so you can use from STM micro to TI, even NXP, and we are working on moving to having ports to other ESP variants and also other silicon vendors too. As for the also support for the Raspberry Pi Co, and also for working with along with Azure IoT. So a lot of things are going on at the moment, and just keep watching on the Discord channel, and you want to join there.
Yeah, Discord is awesome. If you go out to the Nano Framework website, you can join the Discord channel. It's very active. I ask questions there because I'm just a newbie beginner with this Nano Framework. But as a .NET developer and someone who enjoys IoT, I found it so rewarding to get into. The fact that I can connect a cheap device like this to the cloud and send data.
And you feel at home, right?
Yeah, I feel at home. Yeah, it's nothing. There's a couple of bits where it is catching me out, but like we was chatting yesterday, I was trying to get that memory, and it was the fact that the library had changed. I'd updated about 2 weeks ago, and about a week ago, the library had changed, and this new tool come in. It's like, that's how you use it, right? Okay, brilliant. I use that. We've got some questions. So if Adam wants to show some of the questions, I think we had one. Where can you buy the ESP32? Anywhere, Amazon. I really want to. Amir has asked where he'd recommend it. I literally bought these from Amazon, but eBay, Amazon, AliExpress. You can get them cheaper than Amazon, but I like my stuff to arrive next day. So yeah, Amazon Prime, and I bought a pack of 2 the other day. I think it was like £19 something with those boards. Is there an easy way to seal the messages that come in IoT Hub? The easiest way is to use that Azure IoT Explorer. You can see the telemetry coming in. You can use VS Code. There's a VS Code extension, which is fantastic as well. And you can monitor devices in there. Or otherwise, in the cloud, you'd send it out to blob storage and see the device. I think Sander may be covering that later as well. Douglas, sorry if I'm butchering your name there. The Nano Framework documentation only shows setup for Windows and VS. Is it possible to use Nano Framework for Mac and Linux? And is there a plan for VS Code plugin? I think there is. I think there's one being worked on, isn't there?
Yeah, it's on the works. We'll have a Visual Studio Code extension coming up sometime this week, later the next one, which will allow you to code and deploy solutions on your device. It won't allow you to debug directly from Visual Studio Code. That's only on the full version of Visual Studio, but that's a limitation that we have derived from the debugger layer, which is something very complicated to do, and porting that to multi-platform would be hard and very time consuming. That's where we're not investing in there for the moment.
Riley87 says the hub seems fine for data points. What about raw data? Example, high sample time series. Sander's going to cover that later, but you can ingest millions of data points a second. It's always there. You're never going to get a busy signal from IoT Hub. So yeah, as fast as you can send them, IoT Hub can receive them. So you don't need to worry about that. We're sending them quite slowly, but yeah, you can send them as quick as you like. You think. We've only got 1 or 2 devices here connected. I think 4 connected for this display today. But some big companies, Rolls-Royce, for example, the engines on the aircraft that I fly around the world, they connect to the clouds and they send millions of data points a second from hundreds of aircraft around the world. and they're all sent up to the clouds and stored and used and reasoned over, so they can decide whether they need to take the engine off wing to do some maintenance, or they just need to send an engineer out with a care package for the engine to fix it before it even gets anywhere near thinking about braking. Rupesh has asked, is there a way to set up Wi-Fi from Bluetooth? Yeah, you can write the code to connect to Bluetooth, and there is Bluetooth built into Nano Framework, I believe, isn't there? So you can then
Bluetooth is coming into, but the way that you can set up your Wi-Fi credentials is basically from Visual Studio, or you can do that right from the code, and using Device Explorer, as I said. And you can, for ESP32, you can also use the Smart Config application that from Expressive on. Basically, you connect to your device and you send the Wi-Fi details over the air to the device.
Yeah. I mean, where to save device certs on device, what stage to save them. The device certs, the one you get from the SAS key is the one we made in PowerShell. We can also do it in Azure CLI or VS Code. That is the SAS token. The device cert, if we go back to Visual Studio just quickly there, Adam, you'll notice that at the where is it? It is up here. We have the X509. That's the Azure cert, and we have this Baltimore CA cert. This changes, I believe, March next year to a new cert that Azure is going to be using. So even if you're not doing this, but you have devices connected to Azure, you need to worry about that and start thinking about your transition in the next year, in spring of 2022. So this gets it from resources. So in the resources folder, you'll see that there is the Baltimore cert. So we just read that from device memory and read that in, and then use that X509 cert. Again, in the links that are in the READMEs of the GitHub, you'll find how to do this on the samples of Nano Framework on their GitHub. You'll see it there as well. So we can go back to, there's a bit of inception going on, air traffic control. So yeah, you can do it there. You can even do it where I've done it with the resources and put it there, but as Jose says, you can do with your Wi-Fi, you can use the Device Explorer within Visual Studio Nano Framework one, where you can actually upload the cert to the device within that Explorer is the last tab. But the reason I've done it as a resource is so that if you clone this repo, you just need to fill in those 4 bits at the top, which I've showed early on in this talk. And then your device will connect to your IoT Hub or your device provisioning service. So you don't need to worry about the cert. I've kind of taken care of that for you, at least until March next year anyway. And does Nano Framework support C#10 is a question. It definitely supports C#9 because I used the new keyword in there.
Yeah. It supports C#9, and some of the changes brought from C#10 are also supported. We haven't yet moved the project system to go officially with C#10, but that's something that we plan to do in the near future. But all the new stuff that you have from the global usings and all that, not requiring the namespaces and the program main ceremony and all that, you can use that today.
Yeah, I did notice that actually. Last few days, the newer samples are using that.
Yes,
and I was like, is it all gone? And then it twigged in my mind. I was like, oh yeah, they're using global namespaces.
Much cleaner and easier to go through the code. Yeah,
it's much easier. Does Nano Framework allow you to read data from other hardware devices, some sort of temperature reader? Oh my god, here we go, temperature, humidity. Yes, you have your normal device hardware. So if your device like this one has an SPI bus, I2C, CAN bus, whatever, just standard analog inputs for reading voltage input or 20 milliamp input, that sort of thing. Any of those hardware parts that are part of your device are abstracted away in the hardware abstraction layer by Nano Framework. So you can use those, you can connect to your temperature and humidity sensor, drone, or you can connect it to a CAN bus, which talks to an engine management system, etc., etc. You can do all that in Nano Framework.
Yeah, wherever you want from there. And also something important, our API regarding the SPI, SPRC, and all those buses are fully aligned with .NET IoT. Meaning that you can even share code from your Raspberry Pi and Nano Framework with the microcontroller. And also the .NET IoT device bindings, we have about 2/3 of them shared from Nano Framework and .NET IoT. And that's an absolute gold mine for any developer with IoT. And not only if you are doing this for hobby or if you are doing this professionally, it's a lot of value there, being able to grab and use those nuggets there. It's a gold mine.
Yeah. Right, I think we need to move on. Maria Anastasia and Pete are going to move on with some bits. So we're just quickly checking on the flight. So we're moving along quite nicely now. Yeah, we're up at 35,000 feet. So Pete and Maria, over to you. I think we've used a bit of your time, Pete, to get you back.
Yeah, actually, it's Maria Anastasia's time. I'm a facilitator in this particular session. But yeah, it looks like we're all the way over there. I mean, like I say, it's a bit difficult to see exactly where we are. But what's great about this is this real-time, if you will, data being provided to us by the dashboard that Johnny will talk about in his session at the end. Just north of Luxembourg, I'm being told is where we're at. So yeah, that's pretty cool. I do like that. So if we switch across to the slides that I've got here, we'll begin with Maria Anastasia's talk. So Maria Anastasia, did you just want to explain a little bit about who you are and what it is you do again?
Of course. Hello again. I'm so happy that I'm being here today on this flight. So a few things about me. First, I am Maria Anastasia and I'm studying computer engineering and informatics at the University of Patras here in Greece. I work as a software engineer at Team Candy of InfoQuest Technologies and also as a robotics teacher. I am a Gold Microsoft Learn Student Ambassador and I love to give presentations about Azure IoT, and I co-host the IoT Live IoT Twitch show with Pete and Cliff. I have to say sorry about my voice, but my system did not threat this virus in time, and now I speak like that, but I think it's okay. So now you know who I am. Let's get started. Here is our system diagram, and since we have the data from our sensor, and the ESP32 has sent this data to the Azure IoT Hub, it's time to process it. As you can see, today we will see these three ways we can process data. But for now, we will see how we can send them to some third-party services through Service Bus Queue and Logic App. A few words about these two technologies. First, Azure Service Bus is a messaging service that has queues and topics. The most common and these we use today are queues. Queues store messages until the receiving application is available to receive and process them with FIFO, first in, first out method. You can imagine this concept as a queue for bill payment. The first customer who comes to pay his bill will be the first to enter the service queue, be served first and leave first. Next, we have Azure Logic Apps. And Azure Logic App is a low-code, cloud-based platform for creating and running automated workflows that integrate apps, data, services, and systems. Here in our system, the service bus is connected to Logic Apps, and whenever a message arrives at the service bus, triggers the Logic App. We also have connected the IoT Live Twitter account to the Logic app. So every time the Logic app is triggered, a tweet is made, and we will see it live in a few seconds. So, if you want, you could follow IoT Live Twitter account to see these tweets and to be informed about our live streams, of course. Back to our system again. When the sensor detects that the altitude goes too high, ESP32 via Azure IoT Hub sends a message to the service bus queue, and this message triggers the Logic app, and the tweet is made. So now we are going to take a look together and with Pete's great company, our demo. So Pete, if you want, you can, great. We are in our Tech Days research group. Yeah. And we are going to Azure Service Bus namespace.
Let's go there then. Service bus. Here we are. There.
Great. Here we have all the information about our service bus. And if you go to entities and then to queues,
yep,
we can see our queue that has been created. And here it is, the out-of-bounds data queue. So here we can see requests and messages that have been sent. And now to get access to this queue, we need to create a shared access policy. So we go to the settings and then shared access policies. And as we can see, this has been created by the IoT Hub because it's auto-populated. Likewise, the service bus queue namespace has a shared access policy too.
Yep, I'll go to that. There we are. And that's the Logic app one here.
Great. The Logic app give access to this as well, to listen all the queue that come up.
Cool.
So now I think we will go to our IoT Hub. Am I right, Pete?
Yep, absolutely.
Great. And then to the hub settings and to the message routing. And we have to do some things here. First, we have to create a custom endpoint by tapping add. Great. And then service bus queue. And automatically is created a shared access policy as well. Then we're going back to routes. And we can add a new route by clicking the add. And here we put a name. And then we will put the endpoint, our out-of-bounds data. Great. And then data source, the device telemetry messages.
Yep. So this is the data that's coming from the device to the IoT Hub. We can also have things like what happens when we create devices or when devices connect for the first time, or if the device twin itself changes. But we're going to be using device telemetry messages here, aren't we, Maria? Anastasia?
Mm-hmm. Great.
Awesome. So if we have a look at the route that's already there now, this one, then we can see what we're doing.
Mm-hmm.
There we go. So we see we've called this route out of bounds data to service bus because that's what we're routing it to. and we've got our service bus endpoint that we created in the custom endpoints. We're routing telemetry messages. The route is enabled. And then did you just want to explain what this line is doing, Maria Anastasia?
Oh yeah, here is our routing query. And this actually tells that if the altitude is higher than 35,200, correct. This will match the query, and this will trigger our logic app.
It will. We can actually test that here directly. So if we click the message body item down here, then we're looking for this altitude in the body. So I've expanded the message body section. And if I change that to altitude and then get rid of that, and if we do 35,000 feet and then we press test route, then the message didn't match the query. But if we do 35,200, in fact 300 to go above 200, and then test it, then the message matched the query. So this is really handy if you've got quite a complicated query in here. Our query is rather simple, but you could have one that's a lot more complicated than that, and this really helps reduce that development speed for you here. So well worth using that. So that, Maria Anastasia, what you've explained there so far is where the service bus is, and then how we route our out-of-bound messages to the service bus. Shall we look at then the other end of it, where the logic app is connected to the service bus? Shall we look at that?
Great. So we're going again to our resource group. And then, as Pete said, at the logic app. And then we are going to the developer tools. And then here it is, the logic app designer. So first it asks you what trigger do you want to use. So we have chosen message in a queue, because as we said, we have a service bus queue. And then if you tap there, you have to add the queue name, out of bounds data, and in the queue type, we'll leave it with the default choice main. Great. And then we'll leave it probably 10 seconds.
Yep. The default for this is probably in the minutes. But we want this to activate itself a little bit faster than that. So we've set this down at 10 seconds just so that we can have this running live for us and we don't have to wait for a couple of minutes for it to actually happen. So that's where that comes from. So that's where the message is appearing on the queue, and the logic app is triggering when a message appears on that queue. So it's looking every 10 seconds for a message. And if there's a message sitting on the queue, then it'll say, oh, there's something to do here. And that thing to do, in our case, is post a tweet, yeah?
Then we have post a tweet as well. And post a tweet box. And there we can add our message.
Yep, and what's great about this is that you can customize this with dynamic content, which you can see down here. Be careful, of course, if you're sending a tweet. It's going to be public, so be careful about putting information in there that you might not want to leak out of your system. But also, there's a few other things to bear in mind, such as the length of tweets. You're going to be limited, so if you put the whole content in there, you'd probably find that Twitter would reject your request because it's too big for a standard tweet. Also, if you don't put something like this UTC now on there, then Twitter doesn't particularly like you sending the same message over and over again. So you must have some form of a unique identifier at the end of that message so that Twitter doesn't get annoyed. And also there's a rate limit on tweets sent. So if you've got quite a lot of messages that are becoming out of bounds, then Twitter might get annoyed at you there as well. But with all of that in place, I guess actually we could trigger this event. Now, what Cliff has cleverly done in his code, and he briefly alluded to it, is that we can send a direct method down to the device, and we can switch it into sending events that are out of scope. So in the background, somebody's going to go ahead and send that data. Well, I hope they are. I'm not quite sure who's in charge of that in the background. But what we can do is if we flip over to Twitter, and we just wait here a second. There's Maria Anastasia. She's famous at the top of our Twitter profile there. If we just wait a second, we will hopefully, assuming that somebody in the background has triggered it, we will get a tweet appear.
Yeah, I think Cliff will do it.
I hope so. He did say he was going off for a second. Otherwise, we're going to be waiting. Oh, just sent. So it should be coming through shortly. We can actually monitor this as well. So if I go, if I go back to here while we're waiting for that, if we exit back out of this, we get some information here on what's actually happened. So if we refresh this page, we're still showing 2 of these. So I'm assuming. Well, the other thing is we've got to wait for the time lag for Cliff's device to send the next message as well. So that can be up to 30 seconds all on its own. We probably should have sent this before. So if we just go back to the slides while we're waiting for that. Oh, this way. There we are. If we go back to the what we've got here. So on the left-hand side, we've got Cliff's ESP32 pretending to be an airplane. That message from the thing, from the IoT device, has been sent up to the IoT Hub. What Cliff's done in the background is set it. No, I don't. Yeah. We've got a logic app connected to the end of this route, but the IoT Hub has got a route in there that's looking for the altitude to be above 35,200. And if it is over 35,200, that'll go onto a service bus, and the logic app every 10 seconds is monitoring that service bus for a new message. And if it sees that message on there, then it'll send a tweet. And I've been told in the background that it has appeared. So let's have a look. I'll refresh the page. I still don't see it. So somebody says it's there. Tweet not there.
Mm-hmm.
The demo gods again. Refresh that. No, there's nothing being sent here, which is interesting. But we'll come back and check that. 'Cause there's obviously a delay in there somewhere. So it's definitely should be there. But anyway, if we is there any questions that we can take in the meantime while we're waiting for that to come through?
And maybe we can go back to our slides to share some links with the audience.
There we go.
So the first link is for Azure Service Bus, and the second one is for Azure Logic Apps. So if you are interested in these topics, you could learn more there. And the next 3 are for Microsoft Azure IoT developer exam, and the last is our GitHub repository.
Excellent stuff. And yeah, all of the code for today's event is sitting there on GitHub, so you can go ahead and check that out. I'm not quite sure why our message isn't appearing on the service bus. And in fact, I wonder if we can have a look. So how much time have we got left there, Adam? We've got a little bit of time left.
You got a few minutes.
That's fine then. So actually, if we go back to our resource group and we go to the a bit of live debugging never hurt anybody, did it? So if we go to our service bus namespace and to our queue, and then onto the queue, and don't see any messages appearing in that. So that looks like the message itself isn't actually reaching the service bus. So that tells me that it's the route. So what we should do, is that still being sent as errant data now, I wonder. So I'm wondering if it's not over 35,200. I wonder if that's the actual problem. I'm going to have a look at the live telemetry and see what's actually being sent. It's sending 40,000 feet, I'm being told. So that's very interesting. But, you know, it's live demos. They're not always supposed to work. So have we got any questions there? Have we got anything to answer in the chat? Is it possible to send files, blobs to the IoT Hub? Absolutely. There's a process involved in that, but essentially, yeah, you send a message to the IoT Hub telling it that you want to send a file, and then it gives you some information back about how you do that. Now, you need to have connected blob storage up to be able to make this work. But yeah, you can store, say, you've got a CSV that you've filled up with offline data. This is a really good example of information that you'd send up for processing later. So you ask the IoT Hub for the unique URL that you need to send that to, and then that goes directly into blob storage for you. It's quite a useful process. Yes. There we are. Exactly like Jürgen's just explained there as well. So that's good. Is there any more questions? Yeah, I'm not quite sure why our route isn't working. How to schedule to get data from an IoT device on sec-min basis. I suppose to a degree that would be a question for Cliff and Jose. But if I understand your question there, I mean, what Cliff's doing in his code is he's taking from our data from that Flight Radar 24, we get the number of seconds till the next message is sent, and that's essentially what we're doing there. It depends on what you actually mean there, Nadim. Difficult to know exactly what you're asking. As far as the Logic app's concerned, then we've got a polling interval on the Logic app that's looking at the service bus, so we get to define that ourselves. Apologies if I'm misunderstanding what you're asking. It's I could be answering many different questions to that. But Nano Framework is C#, so if it's that side of things, then you can absolutely just set up a timer to be able to trigger at whatever interval you like at that point. To schedule databases on time intervals, yeah, exactly. So you could do all of that in your device code. There's a few different things you could do for an offline type idea. You perhaps want to do the CSV idea that I was talking about earlier. So you collect all of that data, and then maybe once in a while you connect out to maybe a hotspot, a 4G hotspot or something like that, and send the data on that interval. And yeah, really all of that would be in your device code. It'd be entirely up to you to sort out that interval yourself. I can see all those messages are all fine. I'm going to go back to my IoT Hub and have a look at the route and see if I can see why it's not coming out. It's normal.NET C# code, says Cliff, indeed. So if I go back to Tech Days, the IoT Hub, go back to routing, let's have a look. It's definitely enabled. Well, route is enabled, so that should be working. And that is all of the data to the endpoint. That's fine, so that's okay. And the out of bounds data is looking at body.altitude is greater than 35,200. Just making sure that we've not got altitude misspelled or something like that. It doesn't look like it, so that's okay. Let's just save that, just to be sure. You know, live demos. It's all good. But if you keep your eyes on the IoT Live Twitter account, then you will, once we get this working, you'll see that tweet appearing on there. Twitter isn't the only place we can send that. Logic apps will allow you to send it anywhere. I mean, you could send a Teams notification or, I guess, a Slack notification or WhatsApp or anything like that. And yeah, Cliff says he's glad he's not the only one having demo issues. But yeah, so once you've got to the Logic app, then that's great. That's a low code, no code design environment there, and you can just pick and choose, what triggers your logic app and then where you send that data afterwards. So yeah, it's fantastic. So yeah, we'll be doing a little break soon, I believe, for a short message from a special guest, I think. So there's Adam.
That is indeed correct. Yeah, and we'll just brought Cliff back in as well.
Hello. Yeah, I'm glad it's not just me that Demo God's got. Mine was a simple, I missed -- preview off the end of the CLI command. So that's why I couldn't find the file, because I was trying to install a preview version of the firmware onto the ESP32, and it all fell apart from there. But hence, that's tech. As soon as the camera went off me, I looked at it and I was like, "Oh, you idiot!" So, but yeah, there you go. So it's all working now. So the second one has got the firmware installed and it's all ready to rock and roll. But yeah, sadly I missed it. I'm not sure if you've got a wide. Paul DeCarlo's given us a little intro and talk about Azure and IoT, etc.
Spoilers.
Pete, if you want to talk about your Johnny seems to think it's that there's an error in the root syntax.
I don't know about
maybe
that.
you want to look there, and hopefully we can come back to it afterwards.
Well, we've got 12 minutes.
Yeah,
until we're back live.
We'll let you.
But don't go away. Don't go away if you're watching, because we've got an interview coming up with me and Paul DeCarlo in just a moment. So, but huge thank you to Maria Anastasia as well for that wonderful demo, and we'll see you. We'll see you towards the end of the show as well, and hopefully both Pete and Cliff will have fixed their demos by then as well. Anyway, we'll see you all in just a few moments' time. Hey Paul, how's it going?
It goes great, Adam. Real pleasure to be here in the Flight into IoT sessions. This is really awesome. I'm actually tuning in all the way from Houston, Texas, believe it or not, which is pretty awesome. I know y'all are like all based over there in the UK. This is a really exciting event.
Yeah, well, I know it's a very European show today, but we're really glad that you could join us. And, first of all, thanks for speaking with us. It is the middle of the night where you are, so I think we can probably tell people that we recorded this last week at a friendlier hour. But I'm really grateful for you joining us today. And we had just a few quick questions, if you have a few moments for us.
Yeah, absolutely. Would love to talk about whatever. Hopefully it's IoT.
Well, yeah, I think we'll keep it to topic. So my first question today is quite a general one, actually. It's why should people and organizations be interested in IoT in the first place?
Oh, wow. That's a great question. So the thing about Internet of Things that's really exciting for me anyways, is this is when we're talking about employing devices, typically in what we call like edge environments. So like things that are like literally in your points of production or like where your business occurs. What's exciting about that is these devices are typically outfitted with sensors and things that gather data from the actual environment where they're employed. And you can start to see where that becomes really interesting, because when you have data from your actual job site or your location of business and you're producing, say, data and insights in real time, that gives you that ability to react to things in real time. And so if you are a business, a person who's a hobbyist, or an organization that's looking into Internet of Things solutions, there's really a whole bunch of problems that you can solve with this. So think about, for example, you're in a retail scenario and you want to make sure that perhaps people are following safe social distance practices, or maybe you want to look at things like how many cashiers should we have available to handle our queue at specific points during the day. Imagine guessing that number because you're looking at maybe historical data versus really looking out at the actual situation at hand and responding to it there. And this can be extrapolated to so many scenarios. You think of like factory floors where perhaps you can employ some sort of ability to check to maintain that products are being manufactured to a certain spec. Also, like the topic we're looking at today is like safety for things that might be 40,000 feet in the air, airplanes. Any sort of environment really can benefit from this, whether it's on the ground or in the sky. And I think that that's really exciting when you really put this together and you have these devices gathering data in a location and you push that to the cloud. you then are opening up this whole doorway of being able to really solve other interesting problems. For example, how do you store this data over time? As you can imagine, this will probably produce a lot of data. How do you build ML models that might look at this data and be able to react to it automatically? How do you build integrated systems that perhaps look at other things that you have employed across your line of business? All of those become enabled once you have your IoT data flowing into the cloud. And that is hopefully what a lot of folks are learning about today in all of these great sessions.
That's absolutely amazing. And I love all of the possibilities that IoT and all of the related technologies can unlock. But what's the best way for someone that's not used IoT or any of the cloud technologies before to actually get started?
Well, the first thing I want to put out there is don't be put off by the fact that there's hardware involved. There's nothing hard about that anymore. We've actually gone ahead and made a lot of that much more accessible and easy through a number of different services, SDK offerings, and things like that from Microsoft. But if you don't know anything, you absolutely have no idea where to start. Let's say you don't even know what IoT is. I would highly suggest taking a look at Microsoft Learn. And the reason why is we've got a number of free, what we call learning paths that walk you through these entire end-to-end scenarios that have to deal with solving problems in the IoT space. For example, things like looking at how to develop systems that can look at telemetry and respond to anomalies and allow you to visualize that. And to answer that question really directly, we even have a learning path called Introduction to Azure IoT. And this literally goes through everything. I mean, from the defining what IoT is to understanding how you have devices, can connect them to the cloud, how you can actually create services like the Azure IoT Hub to be able to ingest data, learning how you can build full-scale solutions using Azure IoT Central that can allow you to manage devices, get full visualizations and things like that, with writing very, very little small amounts of code even to allow that to happen. And then looking at things like stream processing, looking at how can you handle data as it's coming in real time, looking at architectures for various IoT solutions, and even being able to track real-time data using services like time series insights. So this will really walk you through everything. Again, that's the Introduction to Azure IoT learning path, which we'll have a link below that you can go ahead and check out. And definitely get started there if you don't know where to start. And you can begin your IoT journey today.
Absolutely love it. And we put all of the links on screen as well. Main link is aka.ms/techdays/IoT-learn, but all of the links will be put on screen and also shared in the chat as well. So related to Microsoft Learn, can you tell me a little bit about the Cloud Skills Challenge that we're running as part of 30 Days to Learn It?
Absolutely. Now, this thing is really exciting. So the 30 Days to Learn It IoT Cloud Skills Challenge is a collection of modules from Microsoft Learn that if you complete, you also get rewarded at the end. And that reward is a 50% off voucher to sit for the AZ220 Azure IoT Developer Certification Exam. Now, this is pretty interesting because a lot of the content that's featured inside this collection of modules is really going to map to the sessions you're learning about today. So you're going to learn things like how to connect your devices, how to manage your devices. You're going to look at various different ways of building solutions, understanding the architecture as well. And the great thing there is that if you complete this challenge in the 30 days that you're given, which is, to be fair, more than enough time to do this, you can actually then go ahead and certify officially as an Azure IoT developer. And now the thing that I would really recommend for folks here is that if you're wanting to take this challenge, go ahead and start thinking about that end goal of getting certified, because there's a number of materials out there that you can look at for getting guidance on what's actually practiced on the exam. There's a number of different training resources out there. For example, you can check out, I know Pete Gallagher's on today's sessions. He's actually got a full course on Pluralsight that you can check out that walks you through a lot of this content. So the really interesting thing here is make sure that you sign up for that challenge. And in that 30 days, that if you complete, you will get that reward of being able to take the exam at a 50% discount. You're not rushed into when you take that exam. The only rush, if you will, is completing those challenges in the first place. But these are highly relevant. It's going to give you great skills, and it's going to allow you to interact with Azure services whether you have a subscription or not, which is also kind of cool. So you will be able to touch these services, play with them, get that full hands-on experience that will prepare you appropriately for the AZ220 IoT developer certification.
That is amazing. And so the link is aka.ms/tech-days/IoT-challenge. And we're going to put that link on the bottom of the screen as well, of course. And also just a quick note, obviously Paul mentioned 30 days. So if you've actually entered one of these challenges before and you go in and it says, no, you've already done it, but you didn't finish it in time, don't worry. Actually, you can push leave and you can start it again. And I'll tell you, it'll actually remember the modules that you did before. So that can give you just a little bit of extra time if you don't finish the first time round. But do try and do it in the first 30 days and then get your exam voucher. Hugely valuable. I mean, it's just such an interesting certification in the first place, but massively valuable at work as well. Okay, so my final question for you today, Paul, is, and it's a bit of a cheeky one, it's, can we try any of this stuff for free?
So there's actually quite a few answers to that question. So number one, as I've alluded to, on Microsoft Learn, many of our Azure IoT focused Learn modules allow you to spin up free services in Azure using something we call the Azure Sandbox. So this will actually create like a basically a subscription that doesn't allow or require entering any information other than needing to have a Microsoft Live ID, so some sort of way to log in essentially. Once you have that, you can spin up the necessary services without paying for anything, without handing over a credit card, literally being able to walk through those challenges and utilize the resources needed to follow through without doing anything. But if you want to take that further and really have control and be able to have services that you can define and use yourself, number one, within Microsoft Azure, you can sign up for a free subscription, and that will give you $200 in free cloud credit. That will allow you to explore really the whole range of offerings, not just IoT stuff, everything that's available in Azure. That includes virtual machines, that includes the ability to deploy websites, databases, whatever it is that you need for your solution to be able to try that out today. And going a little bit specifically back to IoT, we do have a number of free tier offerings for some of our services. So for example, one of the things you're going to hear a lot about today is the Azure IoT Hub. And we do have a free tier offering for that, meaning if you activate an Azure subscription, you can actually deploy one of these resources, and it will have a little bit limitations in terms of how many messages it can send and that sort of thing throughout the day. However, it doesn't cost you anything. It will never incur any charges. You're able to deploy one of those, and you can start practicing your Azure IoT skills, whether that's to maybe eventually get an AZ220 IoT developer certification, just learn more on your job or help build that solution that's going to save the day at the workplace. You can do all of that stuff without incurring any costs and learning today. So we definitely encourage you to get started. And Adam, you can go ahead and share some links there to help folks get signed up with those free tier services.
Yeah, well, absolutely. I mean, there's just one link to share on that one, which is aka.ms/tech-days/free. Again, the link is on screen. And that points you both to the list of free Azure services, and also if you'd like to take an Azure trial, you can sign up there as well. Well, Paul, thank you so much for joining us and giving your time today. That is all that we've got time for. So I think with that, we're going to say thanks again, and I'm going to head back to the studio.
Excellent. Well, it's been a pleasure being here, and I wish everyone an excellent flight into IoT event. Cheers.
Amazing. Cheers.
There we go.
Oh.
Thanks, Paul, for that. That was great. We love Paul DeCarlo, fantastic advocate for IoT, and yeah, it's great to see him.
I had breakfast with him a couple of months ago, actually. I flew into Houston, and where he's based, and went and met him for breakfast. So it's kind of cool.
Very
get to fly around the world and get to meet all these people that we kind of tend to do this remotely, but it's kind of cool to meet up with these people and catch up with them and pick their brains that you can't normally do over a chat. You can do over a cup of coffee at breakfast.
I like it. Yeah. Adam, did you want to share my screen before we move on? I know why messages aren't happening, and this is something we knew about, but actually it's a good learning opportunity here.
He's told us this many times over recent weeks.
Yeah, and it still managed to slip through on the live day. But actually, it's a really good point because you may find yourself going through this exact same problem. Now, if you're going to use the IoT simulator that I've got here, and sorry, I can't zoom in very much because it just breaks the UI. It's worth bearing in mind that this is very old software now, actually. And the underlying IoT Hub SDKs, software development kits that this uses, are out of date, and there's some bugs in them. Now, when you send data to the IoT Hub to do routing, it needs to be in a specific format. And for the IoT Hub, this needs to be in JSON, and it needs to be encoded in UTF-8. So those are two very important bits of information. Now, to make sure that happens, you've got two lines here where we set the content type to application/JSON, and we set the content encoding to UTF-8. And that's fantastic, but unfortunately that does not work in the simulator. And it's not implicit, so it's just, you need to actually specify this, and that's what Cliff hasn't done in his ESP32. So although it looks like it's JSON, actually the IoT Hub's not recognized it as that because it's not been flagged correctly. So you can grab that same, see this code here that I was showing you? You can actually copy and paste this into a file on your local system and just run it as a node command prompt. So if I start this running, that would help as well if I actually put in the right data. So I can actually copy the connection string that I've got here. There we go. And this is all going to get shut down afterwards, so I don't mind people seeing that. And if I then scroll right up to the top of my code and I put in my connection string, you can't see me doing this, but that's what I'm doing in the background. And if I start my code back up again, and all being well, we should then start sending data. So the altitude was 0, the altitude is 0, the altitude is 0, and then we should get 40,000.
Send a 40,000, or you done that already?
There we go. There's a 40,000 I've just sent. So all being well, and I've not tested this since I've just done it, but all being well, we should now get a.
Yes.
I'll go back to this. Then if I refresh my screen. Then there we are. Whoa! So that's all it was. So that is that message going through the IoT Hub, through that route, out to a service bus, onto a Logic app, and then been sent out to Twitter. There you are. So that's that tweet being sent just there. So that's your learning exercise. That's the thing to take away from today, that if you don't actually explicitly set that your messages are JSON and UTF-8, those routes aren't going to work, and then you're going to end up scratching your head live on TV. At last, yeah, exactly. Yeah.
We'll come back to me fixing mine later, but I think we need to move on to Sander.
Yeah. So thanks for that. That's good. And there's Sander.
Yes. Good afternoon already here in the Netherlands.
Almost. Yeah, for you it is. Yeah.
We flew past you recently.
Sorry?
We flew past you just a little while ago.
A little bit to the south of the
Netherlands, a little bit south, but we waved out the window. I hope you see us.
Yeah, where are we? Coming into Cheshire. So, coming. So, we've got a little while left before we land, but not too long, to be fair. So, Cliff, if you wanted to de-set your 40,000 altitude now.
I've sent the message. Cool. Waiting for the next one to in queue.
Yep, so we should see that appearing on the left-hand side now. And we'll update Cliff's code to make sure that it's sending everything with the correct markup in there as well, so that you folks don't end up doing what we've just done. But it's all good.
It's just over a minute to the next message, sadly.
Oh, is it? Oh, well,
yeah.
Fair
You
enough,
might want to move on.
Yep, so we'll go ahead.
Shortly.
Yeah. So, Sander, it's time for your particular part of the session, focusing on time series insights.
Yes, thank you, Pete. Thank you, Cliff. My name is Sander van der Velde. I'm an IoT solution architect at Ethos. And in my spare time, I love to share knowledge and sessions and information about Azure and Azure IoT. So Microsoft rewarded me for the MVP award for Azure IoT. Today, in this session, we've already seen that data is coming in the IoT Hub, and we've seen some alerts being sent to logic apps. But, well, there's lots of data coming in, but yeah, we've only seen it with the IoT Explorer, and that's a little bit silly if we just look at single messages coming from a single device. What we are interested in is in all of the messages, and you can look at the data from the perspective of an operator or from the perspective of a data scientist. And each of these group of people have their own questions about the data that's coming in. From an operator perspective, he wants to look at the data of all devices and look at it and try to visualize it and try to see if there's actually data coming in. But he's also interested in, well, the data that's coming in right now, can I compare it to something that happened a week ago or a year ago, or maybe even dozens of years ago when the data was collected? And of course, he wants to compare it within seconds. And from a data science perspective, well, data scientists, they are interested in trends and anomalies. So they want to check out the raw data and figure out if there's already a trend in there. And maybe he can see some anomalies, some outliers. He had some suspicions and he wants to have that confirmed. Well, for that, the IoT Explorer tool is not directly the best tool. There is a better solution. And that's Time Series Insight, because Time Series Insight gives us all of these abilities. It's a fully managed solution from Microsoft. It's living in the Azure cloud, and it is able to ingest that raw data from, for example, an IoT Hub. It can process it to store it, and there are abilities to query the data and even visualize it already. And it can connect both to an IoT Hub, but also to generic event hub. So basically every event that can come in, it's for you to ingest. And because the data is stored in a data lake, you can connect to that data lake yourself and build some tooling on top of it. But there's also already available a Time Series Insight Explorer. Really convenient, and we'll look at it later on. And last but not least, because Time Series Insight is wrapped in a number of APIs, and there's a JavaScript SDK available, you can build your own tooling on top of this. How does Time Series Insight do that? It's a service, and it's as with many pay-as-you-go solutions. We only see the outside, but how is it working from the inside? Well, what we've already seen is, of course, that we get those messages from Azure IoT Hub, and these messages can be ingested by Time Series Insight and processed, because they have to be stored in a very clever way. So querying later on can be done in seconds, even if you're querying data from years and years ago. The data that's coming in is then stored in an Azure data lake for cold storage. All the raw data is going in there. But there's also the ability to have a warm storage. A warm storage is a little bit more expensive, but you can query it as much as you want. There's no extra costs involved for that one. Well, once the data is stored, Time Series Insight also has the ability to model the data. So you can do some basic calculations on top of the raw data. With that model and the raw data together, you can start querying your data and visualize it in charts, graphs, you name it, it's there. So today, in this session, we will look at Time Series Insight and the Time Series Insight Explorer with the data ingested by the IoT Hub. So it's time for a demo. And for that, we go over to the Azure portal. In there, I already created this Time Series Insight environment. It's as a runtime, it's living in Azure, and it's there to be, well, used for you. Look at that, there's this button, the Time Series Insight Explorer, that will bring us to the visual environment. But first we will look at two things. We want to see that Time Series Insight environment is actually connected to an IoT Hub, and that is seen here. We see the IoT Hub. We see that we are using a service policy. We don't need the IoT Hub owner policy. That's too much for us. We just keep it simple. And we take a copy of each message which is coming in. We don't want to ingest all the data. All the services want to have their copy of the incoming data. So we define this extra IoT Hub consumer group inside the IoT Hub. So data is coming in, it has to be stored. So we can see here that I'm actually using a storage account, a blob storage account is used as a data lake. It's living in North Europe, the same place as the IoT Hub is in. And at the bottom, we also see that I have the worm store available. And this worm stores can be up to 31 days if you want to. Well, I just keep it to the 7 days. That's good enough for me. And so we have the data coming in, it's stored. Well, it's time to look at it. So let's open the Time Series Insight Explorer. The visualization tool that is now seen is made up of three main parts. And the first part is at the top. We see all the ingestion of the messages. At this moment, we did some practices already over the last couple of days. I have 2 days and 20 hours of data in here, but I'm only interested in the last part, something like the last 2 hours, something like that. So let's save it. And to the left, we see a number of devices being shown. This can be a long list. If you have hundreds of thousands of devices, that's a long list. Luckily, we only have 2. And I'm interested in the Nano Framework solution. So I go for the altitude. Let's go take the outside temperature, and I want to see the speed. And there it is. We have the altitude. It's rising. It was at 40,000 feet. It's dropping a little bit. The temperature, the outside temperature, well, it dropped fast when we got in the air. And here's the taxiing and flying speed that we see. It's working with swimming lanes, these areas, and we can even put them together if we want to. You can play with that. There's 4 in total, but that's good enough for now, the 3 of them. Well, we can see at the individual values, but we can also put in a marker. And for example, we can put a marker in here. No particular reason, but that's a marker. And you can use that. I am also able to, for example, zoom in for this. So I only see this part, or I can go back. Then I have my original chart again. I can see some data coming in, and the basic statistics like the minimum, maximum, average, and standard deviation. And the data that is seen right now, can also be looked into more detail. Here is the same data which is shown, and we see a number of columns. So we have full control of all the data that is coming in. There's even an interesting solution where we can connect to Power BI. Well, it's not directly connecting to Power BI. What we do is that a query of this information is made available to somebody who is using Power BI, and he can put it in his reports. It's not directly a full solution, but okay, it's good enough. If you have some ideas and you have not worked it out as a data scientist later on, you at least have a grasp of what's going on. Well, this is the data that we see here. It's also possible to do something with time shifting. I copy that same speed, I give it a second color, I put it in the same lane in here. Well, now they are overlapping. So if I change the offset and I say something like, well, 10 minutes, that's good enough for us. Then we actually see that we are able to compare the time, in this case, the speed for 2 points in time. So that could be interesting to compare something which happening right now with something that happened a year ago or 2 years ago. So we are able to manipulate that data quite well. What's also interesting, I take one out, this one. I can also look for outliers. If I take the altitude and the speed and the temperature, then we get this plot. And this plot shows us that the higher the plane is flying, the more speed the plane has. And we also see with the little dots compared to the big dots that the temperature is dropping. So if a point is shown somewhere where we are at a high altitude, but there's a low speed, then probably we have an issue with the sensor, or the plane is going down. But let's hope that's not the problem. So this is the data that we see right now. But what if I want to do some extra calculations? How about that? Well, that's also possible. For that, we go to another page, and here we see the types. I can add own types, and as you can see here, I already created this flight data type, and well, there's the altitude and the latitude. That's the stuff that we normally see, but at the bottom, I also added a few calculations. For example, the altitude in kilometers, the temperature in Fahrenheit, and I can do some aggregations with minimum, maximum, or average of in this case, the outside air temperature. And there's also this stage. And let's look at it a little bit more explicitly. Here I say I'm either flying or taxiing or parked with the airplane compared to the speed of the plane. So what I do, I go to the instances, and this is the actual devices that are known by Time Series Insight because they submitted some data. I can say, well, this is actually a device and it's representing the flight data. Let's give it a better name. It's Nano 1, and because we are able to do that, I publish it, and the same data of that device, the raw data, is still coming in, and we're not touching anything. We are only representing the same data. So I take out a number of these swimming lanes, and I go for the nano, and again I say, hey, altitude in kilometers, the temperature in Fahrenheit, of course, we want to have the speed, and I also want to have the stage. And if I add that, then suddenly, with the same markers still in place, we see that the airplane was parked, then it was taxiing, it was standing still just to take off, and after that it was actually in flight. And we also see the altitude now in kilometers. So if you wonder what 40,000 feet is, it's something like 12,000 kilometers. 12 kilometers high. So this is really interesting what we can do. And then last but not least, there's this long list of possible devices, and it's a little bit bugging me. So what we can do, we can add hierarchies. I added already a few of them about the airports related to the device, the countries related to the device, and even the airline. So let's point our device to all of these hierarchies. And we are departing from London Heathrow, that's I believe LHR. We are going to Budapest. We are starting in Britain, and Hungary is the endpoint, and we are flying with Azure Air. So, okay. That's added, and I go back to the main view, and there we have it. We see that each of these hierarchies have one device. It's the same device, but we can now make a cross-section of the devices and group them in, well, actually any group that you want to. So, okay. We have had a good grasp about time series insight. We've seen how the environment is attached to the IoT Hub, and we've seen how the time series insight Explorer is working. But from a more, well, professional way of working, we are interested in the other abilities. For example, that Azure Data Lake that's underneath time series insight, that can be used with other data scientific tooling, for example, Databricks. And you can maybe combine it with your own machine learning models. But next to it, we also see normally, and that will we see in the next session, the Azure Stream Analytics job, where it is used as a rule engine, and data is sent once after some aggregations or filtering, sent to multiple other Azure resources. What you can do is take that warm path, that warm data from the Azure Stream Analytics, and put it back into time series insight. Then you can go you have a full way to check if the warm path is doing what's expected, because you know the raw data, you know the outcome. And last but not least, you can now build a number of dashboards on top of time series insight. Next to Power BI, you can build your own stuff using the APIs. So, if you're interested in time series insight, well, there's lots of documentation available. There's even a Microsoft Learn module available. It's part of the Azure IoT Developer Exam Reference, so probably you want to look at that also. And I can recommend to look at the Cloud Skills Challenge, which we talked about early on. And if you're interested in what I'm doing, please follow my blog. So, okay, thank you for attending my session. My name is Sander van der Velde, and I'm a Microsoft MVP.
That's great, Sander. Even I learned something there, and I've been playing with TSI for a while. So, yeah.
Yes, when I was asked to do a session about time series insight, you said I said this is my nemesis. But in the end, it's quite useful, and we actually used it for debugging the sessions over the last couple of weeks when we have seen some interesting stuff, behavior of the Nano framework.
It's quite impressive that we just send in a JSON packet from a small little device plugged into a battery that could be in the I've done these devices where they're bolted to a fence post on a farmer's field and send it via 4G. But yeah, you send this data up, and then once it's in the clouds and IoT Hub has received that data, the insights you can gather from it is we just got one device and you're showing what can be gathered there, but imagine if you got 100 or 1,000 devices and how you can reason over that data and pull out, as Pete suggested earlier or alluded to earlier, you can pull out engineering data that us as developers and engineers can use to reason over and work out what is going wrong with the system. Is there something we need to think about? Do we need to change some alerts, some warnings, etc., or even go back and look at historical data? Like you said, we've done some tests over the last few days. You can go back and look at the test we did 2 days ago and see what went wrong there, and look into the data that was received and decide, do we need to change something in the code? And we've done that by putting this session together. But it's quite powerful and really, really clever stuff. But yeah, I'm not sure we have any questions in the chat that Adam can share on screen. But it looks like we're over Slovenia at the moment, so we're just about across the border into Hungary and start a descent down towards Budapest. You can just about see Budapest is on the bottom right corner of the map now. As we started the descent, just passed through 25,000 feet, so flight level 250. And we slide up a little bit down at 400 knots. It's we're going down at nearly 3,000 feet per minute in the bottom right corner there. We started a descent. So we've got Johnny Chips to finish it off. We've explained how this Power BI dashboard come together. But any questions for Sander before we move on, Adam? If not, then.
I think there's been a lot of chatter in the, across YouTube and across the other platforms as well. I think all of those questions have been answered so far. So I think if you want to, we can jump to Johnny Chips, and if you've got any more questions for Sander, we can bring those up at the end in about 20 minutes' time.
Yeah, cool. And thanks, Sander, because you helped us catch up on our flights. We were running a bit late, but you sped through with some insights into the data. We've now caught up now. So I think it's Johnny Chips who's going to show us how to take this data and display it so it's customer focused, customer facing, or even showing to your back end staff. So this could be a dashboard, could be up on the wall in the ops control room at the airline, and they could see where the flights are, track them, and where's flight 1, 2, 3 on its, do we need to get the staff out there ready to unload the bags? It's about to make its approach. So Johnny, over to you.
Thank you, Captain Cliff. And yeah, thanks, Sander. That was great. Am I meant to salute now or anything? Is there any protocol?
We don't do salutes. We're not in the military now.
Fair enough. I'm coming into the control deck now. Then I assume.
Yeah.
Brilliant session so far, guys. Really loved it. So yeah, thanks to everybody involved. And yeah, as you said, then Cliff, we're coming into descent now. We're just coming down towards Hungary, crossing that border fairly soon. So yeah, I don't know, Adam, if you want to flick up my slides and I'll make a start. So firstly, thanks to everybody for inviting me on the show. Thoroughly enjoyed it so far. Really looking forward to talking around the final bit of this end-to-end solution, essentially, which is looking at that stream analytics piece and into Power BI. How can we kind of represent this data that we've got from that physical device right the way through, sending those messages from that ESP32 up to the cloud through IoT Hub, doing some processing, sending some alerts, using time series insights. So my bit now is really looking at that stream analytics. How can we take it further? How can we represent that data in other ways? So yeah, for those of you that don't know me, my name is John Lunn. I am an IoT solutions enthusiast. I bug Pete and Cliff on a fairly regular basis, and I'm not sorry for that. By day, I work as a technical architect at BT Enterprise here in the UK, helping customers on their Azure cloud journey. I am an Azure MVP, got awarded this year, which I was very humbled by. You can catch me on the socials at Johnny Chips on most social platforms, and check out my blog, johnnychips.com. I'm always tinkering around the edges. Anyhow, as I alluded to, we're going to dip into the stream analytics piece and look at that Power BI, that reporting piece. How can we show some cool insights, and how can we actually start to use some of these insights? Looking forward into into the business requirements for capturing this data. How do we represent that in some kind of human readable form? So, as you've seen throughout the show, there's been that map that's been put up. That's a Power BI dashboard. It was a quick way to represent data using some of that information that's coming through from the ESP32 to show a map, to plot a point on a map, to show some of that data that's coming through. And we're representing it on a live Power BI dashboard that you would have noticed was updating in real time, and it's just below me there, and you can see that. I know you'd have to zoom in, but we're going to look at how do we pull that together, how do we get the data into Power BI using Stream Analytics, and how do we take that forward. So first, I suppose the question is, what is Stream Analytics? And not to dwell on this too much, because you can obviously do your own reading through the Stream Analytics docs, the getting started guides, things like that. But fundamentally, Stream Analytics is a real-time analytics. And it's really one of these complex event-driven processing engines that you can kind of use for anything to kind of stream real-time data through it. Using SQL syntax, you can process that data, do some transform on that data, and then send it to an output, send it onwards, as you can see in this diagram or this picture representation. So for our purposes, we're taking data, if I get my little flashy laser pointer, we're taking data from this IoT Hub here. We're sending it through a Stream Analytics job that is doing something to that data, and we'll look into this in a second. And then we're spitting out the other side, and we're using Power BI to do some dynamic dashboarding, which, as I said earlier, is what you've seen there in that flight path as we've come across Europe. So we're going to look into how we set that up, and we'll get to that in a second. I'm going to jump straight in. It's not going to be death by PowerPoint. I'm going to jump straight in. I put these lists of tasks up on the screen here. I'm sure these slides will be available for anybody that wants to kind of dip into this. But equally, we've got a series of links to kind of help you glue some of these things together and join these dots. But you can kind of use this as a little bit of a checklist of things that you might want to think about doing if you're looking to learn some of this for yourself. So I'm going to jump straight into the desktop for a second then. So the first thing that we're going to look at, we're going to run through that list of tasks, is essentially we're going to look at these links. So getting a Stream Analytics job quickly up and running, getting that set up through the Azure portal. We're going to be looking to ingest some data. So ingest that data that's coming out of the IoT Hub into that Stream Analytics job. And then we're going to send that over to Power BI somehow. We're going to explore that and understand what's involved with that. So we've got fundamentally 4 areas that we're going to look into. So all of these links will be available. I'm sure Adam will probably throw them up on the screen as and when we start talking about it. But to begin, the first task that we need to do, if we're looking to send any form of data into Power BI, the first thing that we need to do is besides having a subscription, having some licensing in place, is we need to log on to our Power BI workspace. Now, ideally, we want to create a nice, fresh workspace. You can see I've got one here called Tech Days 2021, which is the one we're going to be talking about at the moment. But it's a very simple task to create a new workspace. We come into we log on onto Power BI. We give the workspace a name. We click Save. We've got an empty workspace. Now, a workspace in Power BI is an area that we can use to store our components that go into building our dynamic dashboards up and things like that. But we need to set this up first, because actually when we jump over to the Azure portal in a minute, the first thing we need to do with our Stream Analytics job is tell that Stream Analytics job where do we want to send the data. So if we've not got a workspace available, we'd have to go off and create it then. So first step, we've got a nice, in my case, it's not empty because I'm going to talk you through all of these, but you would have a nice empty workspace there. The next step that we want to do now is we want to jump over into our Azure portal. So as we've been using right the way through these sessions, we're going to look at our IoT Hub first and foremost. And it was alluded to in the previous sessions. Maria Anastasia alluded to it when she was talking about the Logic app and the service bus getting messages from the IoT Hub. We're no different. We are actually going to be using a built-in endpoint of the IoT Hub. And these effectively are, we talked about that pub sub, that kind of that topic relationship, those message queues, first in, first out. I'm actually using what they call is a consumer group called SAS, Stream Analytics Service. Effectively, what this does is it enables my Stream Analytics job to hook into the IoT Hub to grab the messages from a consumer group that I'm going to label SAS. And all that really does is that it enables the IoT Hub to mark a message as read by an application that is purporting to use this SAS consumer group. So in other words, if I have a second or third or fourth application coming in to that IoT Hub, I'm not going to get my message already marked as read, because that can start to create confusing results. So that's the first thing we need to do, is create our new consumer group. In this case, it's called SAS. And then the next thing we're going to do is jump on over and actually create our Stream Analytics Services job. So in here, we've got one that we've obviously created earlier for the purposes of this demo and this flight today. So if I jump into the Stream Analytics job, very simple through the Azure portal to create, and you can follow along using that link, that quick start link, create a Stream Analytics service in the Azure portal. So when you go through, you create one of these jobs, the first thing that you're going to need to do is create an input. And within that input, what you're actually doing is you're declaring where are you receiving your data from. And in this case, I know it's probably slightly grayed out here on the screen. Hopefully it's coming through. You can just about read it. But I've got an input called Tech Days 2021 IoT Hub. I'm actually pulling it from the same Azure subscription from my IoT Hub that's actually created, that Pete created earlier on in this presentation. And you can see just about here that I'm actually saying I want to use the consumer group SAS. I'm using the shared access policy name of IoT Hub owner, but this all can be populated via drop-down boxes. And literally we can say, okay, there we go. I've just hooked up my Stream Analytics job to my IoT Hub. And in that point, we should then have messages starting to flow into our Stream Analytics Services job. Once we've got that input sorted, the next thing to do is, clearly, we need to create an output. We need to send that data somewhere else. So you'll see here through the portal, I've really just come onto the overview page of my Stream Analytics job. By default, you get one output that you can name anything you like. In this case, I've actually got two outputs. So the output that I'm actually using is this output, Tech Days 2021 output Power BI or PBI. And you can see that the kind of information I had to present in order to hook it up to my workspace was the group workspace GUID. Again, this is all going to be trash at the end of the day. You can't do a lot with it unless you can authenticate onto that workspace. And another thing to point out here is you'll see that I'm actually logged into my Azure tenant using one set of credentials, and I can actually send data through to a completely separate subscription or licensed instance of Power BI, and in which case I'm using a different set of credentials to actually authenticate onto my Power BI workspace. And actually what I'm doing is I'm authenticating onto two separate instances, one which I have credentials for and one which Pete has credentials for. Mainly because of this demo, Pete was looking, as you saw at the beginning of this session, he sent data through that Raspberry Pi simulator that was quite quick. It takes about 10 minutes to send all those data points. Whereas now we are sending data from our flight AAW 874, which is London Heathrow to Budapest. And you can see we're actually using the Stream Analytics job to do that for us. So once we've got our inputs and outputs, so imagine inputs coming from IoT Hub, outputs are sending to two separate Power BI workspaces. Great. So what can we do then? What is that bit in the middle? How do we control that bit in the middle? So in order to kind of jump into that, let's click on Edit Query. And you can see that the syntax is very much SQL-like. This isn't as basic as it could have been. I think when we first set this up, the first thing that you get is a very simple SQL query, which is select star, select all. So in other words, select every record that's coming in and send it to my output location from my input. So in other words, anything that comes into the input, send it straight out to the output. As I mentioned just now, we've slightly tweaked that because we wanted to put a little bit of filtering in place. And this is a valid thing that you can do now. You can use your imagination or creativity or understand what that real business thing is that you need to do. And you can start using Stream Analytics, not just to send it from one point to another point. You can send it to multiple endpoints. You can do some transform on that data through the power of this SQL query that you're going to be putting in here. We're trying to keep it as simple as we can for this demo. So all we're doing is we're splitting anything that has got the call sign AAW874, which is we've not got on the screen out at the moment, but that's the call sign of the real-time flight as it's coming over from London Heathrow, which actually is not far off landing now, I believe, everyone. If you want to flick that up on the screen there, Adam, for a brief second. So you can see that's our flight AAW874. And yeah, just looking at the screen, we are, I'm going to zoom in there. We are just on the final approach towards Budapest there. So yeah, should be timed quite well. Give it another 5 minutes, so we'll come back to it. So yeah, if we want to flick back to my desktop there a second, Adam, all we're actually doing is separating those two flights. So Pete was using flight 888 on his Raspberry Pi simulator earlier, and we just use that as a point to branch the data, just not to confuse ourselves with the data. So Pete could do his testing, and we could obviously do the real-time demo using the 874 flight call sign. Okay, so once we've got that in place, the next thing that we want to do is really understand that, well, where is this data going? So in effect, we set up our outputs. Is that it? Effectively, yes, that's it. We'll move on. So at this point, we'll browse back over to our Power BI workspace. And the first thing that you'll notice is that when we set up the output, the data set that we actually labeled in that output is appearing here as an object in our Power BI workspace. And that's the first thing that you'll notice is this data set object appears, which is great. In theory, that contains all of our data as it's being streamed over from Stream Analytics. Superb. What do we do from that point? Well, the next point then is to layer on. We'll use a tool called Power BI Desktop. So there's a desktop version of Power BI that you can use, that you can author and create Power BI reports or dashboards, and that's what we're going to do. So what we did in order to get the real-time updates, we use a dashboard. So I'm going to browse into a little bit more of a comprehensive report that's using the same data. I've literally created a brand new report in Power BI. I've hooked it up to that data set that's sat in my workspace through a simple mechanism of just signing in, selecting that data set. And you can see there straight away that I've now got the ability to drop all these different visualizations onto my Power BI report and actually start doing stuff in a relatively straightforward way. And now if I click on any of these data points, you can see I can start to get interactive charts going. Obviously I can start to color code the charts in terms of green, in theory, meant to be good. I've actually color coded, when the flight is close to the ground, it's red. As it gets higher, it goes through an amber stage. And when it's up to its flying altitude, it's green. The point here is we can start to visualize the data in a way that's meaningful to the thing that you're trying to represent. So, this was my visualizations, my idea that, look, if it's green, in theory, we can glance over at a dashboard or a report and go, well, it's all green, we're all good. If there's any red coming into play or orange, oh, hang on a second, orange, something is going on there. And indeed, something is going on. The flight is actually descending now in towards Budapest. When we're in the Power BI dashboard, we've got the ability to drop any of these visualizations. So you get a whole bunch of different visualization types that you can drop straight onto a report. In order to represent the map, for argument's sake, we've got a map visualization. Now, if we use the fields here, the data fields that we're actually looking at, you can see that part of the data that the ESP32 is sending through and the code in the Raspberry Pi simulator is a latitude position and a longitude position. Now, with the map object, we've got the easy ability to literally drag and drop that latitude and longitude into those representative fields within that visualization, and straight away you get the ability to see where that data point actually originated from. So you can see that I'm not doing any coding. This is kind of citizen development, if you like. There's no real coding going on here. If you're comfortable with Excel and those kind of ways of working, then you can very quickly get into the use, using Power BI dashboards and building these visualizations up, relatively quickly with minimal effort, in all fairness. The next thing that you can kind of do is any visualization. So at the moment, I've got that map visualization selected. We can drill on into the formatting, and we've got a whole bunch of properties and parameters that we can set in this particular visualization. Things like what color do we want our data to be represented by? So, at this minute in time, I'm using a bit of a formula, which is a bit like conditional formatting, where the lowest values you have a certain color, you might have a mid-range that changes to a different color, and so on and so forth, up to a highest value, in my case being green. And all we're doing is, we're using that color format, and it will automatically take care of those visualizations. If I just quickly refresh that data. The only thing is, I'm not going to go into it in great detail here, but where the Power BI desktop, I'm manually refreshing these pages at the moment. I'm just zooming in a little bit more, and it looks like we are, I don't know where the airport is, Cliff, but it looks like there's a runway there, so we're not far away. We're probably about 5 minutes or so away from the airport. So I take it we've got the cannons going off now when we actually land, yeah, everyone? So I'll wait for that to come in anyway. So yeah, just a few more bits and pieces about these visualizations. Like I say, we can select a point. We can see the current speed of the aircraft is currently 134 knots. We're just over 1,000 feet in altitude. Wind speed is 10 knots. We've also got all of this other great data. You might have remembered Cliff earlier on showing the ESP32. He had a function in there to convert the degrees, which is a number between 0 and 360. He's running a function that actually represents that as a text string: north, southeast, southwest, south, whatever it may be. And we're simply representing that. So there are ways that you could actually do that transform in Stream Analytics. You could potentially do some of that work in the Power BI dashboard. The point is, you've got a lot of great flexibility. So anyway, what we did then from that point, as far as these visualizations go, we actually created a dashboard view. So if we flick back over to my Power BI workspace, and what we were trying to do, because we wanted to show this as a real-time update with dashboards, you've got the ability to add real-time tiles that update, as the name suggests, in real time. So that's what we chose to use. I mean, there are some pros and cons. There are some disadvantages with that, but equally there are some advantages like anything. We might dip into those now during the Q&A session, but fundamentally what we've got here is that we've got a dashboard view now that has got an embedded version of a section of my report. And this report is just sat there in the middle of a few live tiles. And we could actually go and add another tile. We could add some custom streaming data. And because we're hooked up to this Tech Days 2021 Power BI data set, I can click next. And I could, in theory, add, you do have a cut down version of live tiles that you can use within a dashboard, but it's still good information that you can put in there. So for argument's sake, I could include a gauge, and maybe I want to include a gauge on my altitude. And just quickly, just click next. And if I apply that, in theory, I should be able to, in a second anyway, hopefully start seeing some real data come through and represented in that altitude dial, or gauge, which I'll try and make a little bit smaller there because it's a little bit big for my screen. But yeah, so basically you can add as much information to this dashboard as you please. So there we go. I'm just getting a message from Cliff. We have landed. I was expecting you all to kind of break in at that point and start clapping like they do on a real flight. So there we go.
They don't clap for my landings, but yay!
So if we zoom in, and that's really good timing. Oh, so what runway is that one there, Cliff? That seems to be not the...
be runway 13 right, I think it is, in Budapest.
There we go. So
Yep.
next time you're going to Budapest,
Yep.
I just done a quick refresh of the data there. So if I zoom in, if I can control my mouse.
Yeah. So we landed 13 right at Budapest, and yeah, so we'll be taxiing off, and just where it says Bucharest, and it's got a little airport symbol in the middle there. That's where we'll go and park the aircraft. And at Budapest, we park on a remote stand, so it'll be buses into the terminal, and then you go collect your bags. But yeah.
Awesome stuff. Well, there we go. That was great timing. I mean, the only thing I was going to add to this now is things about publishing. Once we created this Power BI report, or the report in Power BI, we got the ability to publish it, which I could click there. I'm not going to do it because I've already published it, and that report itself will appear in our workspace. And in fact, there's our report, and we can get a real-time view of that report through a web portal. And the only thing I wanted to add from that is, look, it doesn't stop there, really. We could edit this, so we could view this report in a different format. So if I were to edit it and click on mobile layout for argument's sake, I can create a mobile version of this report. So now all of a sudden, and in fact, I forgot to sign into it earlier. I was going to actually sign in, so I'll see how quickly I can do it on the fly. But I'm on my Power BI dashboard on my phone, and if I click on my workspaces, Tech Days click on my dashboard. I'll hold it up to my camera there. I don't know how great you'll see that, whether it will come through. No, it's a bit too... You can just about see it there, but I got the actual report there. A bit too bright, isn't it? Maybe I need to turn my lights off.
Too many Elgato lights you've got there.
There's too much camera work. But anyway, you can probably just about see it there. But I've got a representation of this dashboard appearing on my mobile device. So you can start to see from a business point of view, we've got the ability to represent the data on a web page that we could share out with other people, across the business. We've got the ability to share this out through a mobile app, so that you can view that. So on that note, I was going to talk about, taking this further and using Stream Analytics and Power BI for a little bit further, but maybe we'll just break into the Q&A session, guys?
There was a quick question that I spotted there already, which I know you and I know quite a lot about now. I forget who it was that actually asked it. Nagandra has asked, are there any restrictions on Power BI to refresh and get real-time data?
The answer is yes. Yeah, absolutely. Now, I'm not going to profess to be the absolute knowledge of this because I believe it brings licensing into play here. So the easiest way for me to try and explain this then, and the way that we've got this setup working at the moment, is we've got it working and refreshing automatically using live dashboards, which is that view that you can see just to the side of me there between me and Cliff on the screen. That's using a real-time dashboard. So by default, if you pin a report or any of those live tiles, they will update in real time as data is pulled through from the data set that sits behind. When it comes to using something like a Power BI report or Power BI desktop, then you absolutely do have the ability to set your page refresh time. So if I click down here, you might just be able to see it, but you've got the ability to set page refresh down to a second if you so wish. You've got to bear in mind that each of these visualizations are going to be calling off a query to your database. Now, our database is sat in a Power BI workspace, which is a shared environment. So you imagine if I've got probably about a dozen different visualizations sat on this report. If I set that to refresh every second I'd be getting 12 calls to my back-end database. Now, let's scale that a bit further. Say I shared this report with 20 of my colleagues, and they all had it open on their screen. You can start to see how exponentially those calls to the back-end database would scale up quite quickly. So when it comes to licensing, by default, my workspace is in what they call a shared workspace on shared compute. You can actually purchase dedicated VMs to run this on, in which case you're able to kind of scale those numbers down to a second or 10 seconds to kind of refresh that data to suit, because you're running that against your own dedicated hardware. But of course, like anything, that costs a bit of money. And you can see there, but by default, you've got, I believe, 48 times a day, which is every half an hour. You can refresh a report is what you get from the shared workspace. There are other nuances around that. I'm not going to drill into it, but hopefully that gives you the theme that you can kind of either have a chat with your licensing person or understand what licensing you've got from a 365 perspective for Power BI, and do you need to do anything more?
I think there's another question as well from Vipol. It's just moved up on my thing. Can we integrate vision camera into Power BI? Oh, there you go. Thanks, Adam.
Can we integrate vision camera with Power BI? I mean, what you get out of the box is a whole bunch of visualization out the box things. You've got a marketplace you can go to for visualization. Not actually looked myself, but you've got the ability to build in a Python visual. Now, I'm not going to say anything about that. I think we might need to come back and see if we can find it. But with Python, as we all know, it's quite a, it's a programming language essentially. So I wouldn't be surprised if we could pull some kind of visualization. But don't quote me. I'd have to come back and see if there's, any reason why that's not a good idea. So yeah, maybe park that one unless somebody in the chat knows for sure whether we can do that.
I wonder, would it be? Is the actual question, say we're using that ESP cam device, if that was to send images from that to say storage or something, could you pull it out of storage and show it as a visualization? I guess if you could surface it on an HTTP, on a web page or something.
Yeah, well, to be honest, Pete, yeah, I mean, when you look at the dashboards, so I mean, just to kind of maybe discuss out loud some of those potentials, when we look at the dashboard, if I'll just quickly call it up here on my screen. here, Tech Days. When we import a live tile, we can add in an image tile. Yeah. So on the dashboard, when that eventually wakes up a little bit. So we can add in an image, and that image is the endpoint for that image is going to be a publicly available URL. So if you do service those, I mean, I guess it doesn't have to. I'm not going to get too technical, but you could use private link and start hiding your storage accounts, behind a private network. But let's just say for proof of concept, we could have a URL that points to a generic name called current picture.jpg sat in a public storage account. There's nothing suggesting that you couldn't, with the ESP, update that image on a periodic basis with the last snapshot from the camera. And then when that dashboard refreshes, it's just effectively pulling the latest JPEG from that storage account. But as in real-time video footage, it's like anything. It's like anything. I'm not going to say that there's a tried and tested method and there's a docs article available for use, but it's like anything. I'm sure there is, where there's a will, there's a way, eh? And you've got two fine developers on the call here that I'm sure would find a way of doing that, something like that.
If you press the back button as well, if you press the back button there, then there's web content there, top left, and also video as well. So
there we go.
Different options. So
helps if you read the tiles, eh, Pete?
That's all right. Yeah. A few different options.
Yeah. Before everyone comes back, though, I just want to show Adam, if you don't mind, just showing my screen. I want to show why the demo got me, what it was that got me. Anyone that follows me on Twitter will see the fact that all I missed was -- preview off the end of the Nano command. Because of that, it wasn't picking up the preview version of this ESP32 firmware that I'm using on the board. So literally, as soon as my demo finished and we moved on, and after the Q&A, I went in, I noticed that was missing, put it on the end, and literally you can see it's run there. So now this ESP32 that I've got here, which was brand spanking new before the show, has now got the Nano firmware loading. You can now see that up on my Visual Studio instance. You can see I've got the device there, so I can now go into edit network configuration, which will open up the network load. I can go into the Wi-Fi profiles. I'm not going to do it because it will show my Wi-Fi credentials of my office here. But you can also go into the end and upload that root certificate and device certificate if you want to there, rather than having it in code and a shared resource. And it also means I can click a deploy there, and you'll see the fact that it's deploying and it's sharing the device down the bottom here. And view, where's output gone? There we go, output there. You can see it's deploying all the code down to the device, and then we can, if we're quick enough, and we go up to the beginning here, we can have we can put a debug in there. Where's the output gone? There we go. So it's loading it all up. It's downloading all the DLLs down to the device. And we'll see shortly that it hits that breakpoint. So now we've hit the breakpoint. So just to prove the point, because I don't want you to go away and think, oh, Nano Framework's really bad. It was me. I made a mistake and I made a typo, or not a typo. I forgot to type the keys. And that's all pure because I did all my testing, my training, and my setup on my laptop, on my Surface Book. And because my wife has come down with COVID, I've had to decamp out to the workshop, and the PC here wasn't set up with everything. But if I click continue there, we'll see the fact that this now goes off. And it gets off an IP address. I'm not sure if you can make the code bigger down there or not. You can see it's going off. It's connected to my Wi-Fi network. It will get an IP address. It takes a little bit longer because it's a new device. It's never been connected to the Wi-Fi. So it goes off and gets DHCP address and everything else, and it will connect up and work. And then it will connect up a DPS, device provisioning service, get the connection, read the SD card, and start sending that data up to the cloud. I just want to prove that it works, and it's there. It will just take a few more seconds to do that. But I'll let you go back, Adam, to showing everyone's faces, and we'll have a final Q&A.
Yeah, I just wanted to let Johnny Chips just go through his quick links, because we didn't do that right at the end.
Yeah, no, thanks, Adam. So yeah, for anybody that's looking to delve into this, I know it was a bit of a whistle-stop tour through Stream Analytics, and look, it's such a hugely powerful feature that you can use. Look into cloud jobs versus edge jobs, things like that. There's some great stuff that you can do with them, and then bring that into Power BI. So there's kind of 4 links on the screen there to get started. That quick starting guide to get you set up with your first Stream Analytics job in the Azure portal. It's a great guide to go through. I encourage anybody to use that. Then look to ingest some data into that stream and look to start playing with it, manipulating some of that data, and seeing what you get out. Flex your SQL muscles, so to speak, before moving on and doing a similar thing with Power BI. If you've not used any of the Power Suite yet, it's another fantastic group of products, from Microsoft, obviously, that you can do some really great things. So there's a couple of links there to get you started with Power BI if that's of interest to you. So yeah. On that note, that's me finished off. So yeah, thanks again, everybody, for bringing me into this. It's been a great flight.
That's smooth landing as well. We timed it perfectly.
We did.
Yeah, it's the whole team that's been behind this whole lot.
That's right. We brought a couple of extra people in so that we've got Gosha Borcheska as well as Jürgen Cavalier's down here. They've been supporting us in the chat behind the scenes. So thank you so much for your effort behind there as well. You've been fantastic. And then obviously we've got to thank Adam Jackson here in the top left for his amazing support behind the scenes there running the event, as well as Sarah Allison and Rena, as well as Layla, as well as there's been a whole heap of people that are really
Lewis as well, who's kept us saying.
Absolutely. Yeah, quite right.
Thank you to Layla and Lewis. I think we missed a couple of minutes off one of. I think we were broadcasting to about 4 or 5 different places today. And you may have missed a few minutes at the start, but don't worry, because it was an introduction to what we were going to cover. And actually, immediately after this show, you'll be able to watch this on demand via ak.ms/tech-days. So you've not missed anything, and hopefully you got to ask all the questions that you wanted. And I know that there's been lots and lots of questions. Seen really great engagement from everyone today. So thank you for keeping those questions coming. And for everyone that's supported today. Do we want to share a couple of links? I think we've got Cloud Skills Challenge, things like that, haven't we?
We have, yeah. And if anyone's got any questions after the event, below all of our little faces is our Twitter handles. I'm sure, certainly for myself, quite happy to answer questions on Twitter. And I'm pretty certain, yeah, there you go.
Very small.
And find us there. There you go. There's my Twitter handle. You can't get me there. And Pete as well. And Sander as well, and everyone's there. Tick all the bits. If you want Nano Framework, and Jose's the person to ask. Maria Anastasia is awesome, and congratulations on passing your exam recently, Maria Anastasia. And she's in sunny Greece as well. We did want to fly all the way down there, but we couldn't quite make it. Gosha, thank you for answering questions out in the chat. Been awesome. And Jürgen, if you do go and do your AZ220, if you go on Plural's site, Jürgen has got some of the courses as well as Pete. Jürgen's courses are spot on. I learned a heck of a lot from Pete and Jürgen's courses. A few other resin out there as well. And Adam for being air traffic control today, and team engineer, pushing all the buttons that need to be pushed and get the things in the right place. Thank you very much.
Brilliant. Well, our flight has landed, hasn't it? Take one last look at that. There we go. It's certainly on the ground now.
Yeah.
I'm just glad we didn't have to use the emergency exits.
I just noticing a quick question I'll ask if we've got a minute or so left. Gershon Kumar in the YouTube is asking, from IoT Hub, is there a way to retrieve the total message count for a specific device? That's in the IoT Hub. You'd obviously go in and select your device. It does have a count, doesn't it, Pete? I think.
Yeah, you're best off using the metrics at that point. And then you can do your own filtering in there. So along the left-hand side in the menu, you'll find there's diagnostic logs and metrics. And if you use metrics, then you can do your own filtering in there.
I asked you, Pete, on purpose, because I know you've got a great plural site course on exactly that. So do go out to find Pete's AZ220 courses, and he does have one on metrics, which covers exactly that question. in great detail. So
I said he could show the link once, and he's shown it twice. Like, it's a paid-for link, everyone.
Yeah. Is there any last questions on any of the many platforms that I can only see the YouTubes at the moment? I'm not sure if there's any others, Adam, that you want to put to the team.
I think Nadeem has asked, is there a QR generators and barcode generators and reading in Power BI?
QR generator and barcode generator.
So is there a QR visualization, I guess, and barcode visualization?
I suppose it's just an image, isn't it? And a QR code. So you just need a bit of back-end code to create a QR code and show it, as Johnny mentioned earlier, as an image. That's essentially all you're doing, really, isn't it? Yeah. Depends.
Yeah, it is. I'm just having a quick look in the marketplace to see if there's anything, but yeah, it is just an image. It's normally a database that actually generates those images. I don't think there's anything built into Power BI, but you might find there's a third-party resource that you can get that image generated for you to then obviously display in your dashboard or your report. But I was just having a quick look at the marketplace. I can't see anything obvious that jumps out there. But
there's lots of C# and .NET libraries that you can use for doing that sort of thing. Zebra Crossing is one that I use in mobile for creating and reading QR codes, because barcodes are like a Zebra Crossing. So
we are out of time. We are out of time and about to get cut off, I believe, as well. So we're gonna wave. We're gonna wave and say bye and say a huge thank you to everyone that supported the show, particularly Cliff and Pete for being our pilot and our captain and first officer. I'm not saying which one's which. And now we must leave you, but thank you for joining us for this Tech Days, and we'll see you again soon. Quick note: this will be available on demand at Tech Days, aka.nms/Tech Days/IoT. And I am going to go to the closing slide because we are literally going to get cut off now. Thank you again. Bye.
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 Bye.